Oh baby, I know we can make it. Take it easy. I know we can make it. You take it easy. I know we can make it. You take it easy, babe. I know that we can make it.
Yes. A very good morning to all our esteemed guests. Welcome to the SARChi Chair in Enabled Environment and Assistive Living Research and Innovation Seminar. Welcome this morning. We are going to go around to the exhibitors and we're going to find out about their innovation and research. Please join me as we are going to walk about. Thank you. Yes, shall we go? A very good morning to you, sir. How are you?
I'm very well, thank you.
Can you please tell us about your display, what you're exhibiting here, and how it's impacting the enabled environment and assistive living? Thank you.
Yes, I can do so. Should I hold this? So what we do is we do first robotics, and it's a program for school children where we stimulate an interest in science, engineering, and technology. And we start from 4 years of age and we go right through all the way up to 18 years of age. And that is where they get the interest in robotics and automation. And that is the fee that we use then to attract students to come to TUT. It's not a TUT initiative, it's a global initiative. So we partner with other universities as well, because we find that sometimes you have a staff member from TUT, but then they get an appointment at UNISA or at another university, and many years later, they might be coming back. So we're developing engineers and scientists for South Africa, and that is what this program is about, and that's why we collaborate with other universities as well.
Fantastic. Thank you so much. Any other developments you'd like to share what you're displaying here?
So what we have on display here is one of the robots that was built by a high school team. And it's just to show the complexity of the robot. And then we have the engineering notebook, because we're not interested in the end product. We're interested in how did they came to the solution. So this engineering notebook is what they're being judged on. So they need to present that to a panel of judges, which is then engineers from industry. And they explain what was the whole design process and how did they come to manufacture this robot, how many iterations did they go through, what challenges did they encounter, and how did they solve those challenges. So that is what this display is about.
Fantastic. Thank you so much. Any inputs you'd like to make?
Thank you.
Oh, at this stage, you're fine. Thank you. Let's move on to the next exhibitor. That's right. Yes. A very good morning to you, lady. Yes.
Good morning. Good morning. How are you?
I'm very well, thank you. Yes, would you like to share with us some insights on this equipment and how it is contributing to the SARChi innovation and research?
Okay, so this is one of the projects from SARChi in the enabled environment. It's a rehabilitation device, a smart rehabilitation device called the robotic rollator. What it does is that it makes use of the user's own movement in order to navigate itself. That's the first part. The second part, it's twofold, is to have, as you're measuring the user's movement, you can log it in and have the therapist compare it, map it onto how they're actually supposed to work in order to assist them to better be mobile.
Fantastic. So how is this impacting then the life of those that would be actually using these devices?
Okay, so if you see what currently is on the market, you do have passive systems where the person might have to use their upper body strength in order to relearn how to walk. For this one, you don't need much of any upper body strength or any cognitive ability because it makes use of a person's mobility. So they actually use it without actually having to walk or think of how to maneuver the device.
Oh, wow, this is quite a great innovation. How fantastic it is in assisting in living in these times of digitalizations. Any other, perhaps maybe you want to exhibit or display how one would actually be, demonstrate to us actually how this would actually work, and just to get an idea of really how that could be. Any? Yes, question.
Yes, thank you so much. We're excited to be here today. Thank you so much. I am sure the world is thinking that maybe these are being made somewhere, they're being manufactured somewhere. Can you tell the world that these are manufactured in our university? And how did you go about together with the team to end up being in here? We're talking about the technology that is being manufactured in our very own university, the People's University.
Oh, wow, yes.
Yes, this is proudly Tshwane University of Technology product, proudly SARChi product innovation. As I said, it ranges from the labs of SARChi right here at TUT. This was my master's project under the supervision of Dr. Steyn and Prof. Hamam. So yes, it's a proud innovation of TUT and we're planning on growing even more.
Oh, wow, fantastic. This is thoroughly exciting. Do you perhaps want to do for us some demonstration as to how this wonderful innovation actually, practically, just to give a demonstration?
Good morning. Solofelo, will you be able to do this one? Okay, let's do the robotic walker. I can quickly show you that as well. It's not a problem, the wheelchair, but let's maybe just see if we can get this up and running.
Okay, fantastic.
Maybe first this. Okay. First do this. Okay. Can I just maybe quickly explain here?
Yes.
So if you look at it over here, it's just, well, basically it looks like a normal wheelchair. But one thing, it's basically a hybrid wheelchair. So it is electrical wheelchair, but also you have still the ability to basically move it manually, meaning that it augment the person, help a person. So if he has some kind of upper body delimitation, it means that you can still augment that part and also maybe moving on difficult terrains as well. Furthermore, as I said, augment again. So you're not taking away by fully putting a person in an electrical wheelchair, but you're still giving that ability and also self-independence that he can still use the wheelchair. So if you will not be able to use a manual wheelchair and something in between that was missing. So this basically then replaces that, and that's why I said it's more a hybrid type of system. If you look at it, you will think it's a normal wheelchair, but on the wheels itself, it picks up then the movement that the user actually wants. And from there, it augments then that movement. So I can quickly show.
Fantastic. Ladies and gentlemen, we are looking at how this fantastic equipment is operating.
So now it's just a normal wheelchair that you can move around with. Even if you look at the footprint, it's a lot smaller than a normal electrical wheelchair. But then you can put it in a mode where it's basically self-augmented. Then it means that a person can still use his upper body to move around, but it basically assists in that person in that. So if you push this, you can see it's just a lot easier to move around. You can stop and yeah, and turn and all of that. And so again, you're giving that, you're not taking away the self-independence by just using an electrical wheelchair, but you still have this augmented part, and the person still feels that he's in self-control and that he can move around on his own.
Wow, this is fantastic. Not only are we in hybrid environments, but we also get equipments that are hybrid. Thank you so much. Thank you.
Thank you. So to navigate the wheelchair, it's twofold. You can either use the pressure sensors to move it forward and backwards. Again, as I mentioned, you can even use your upper body, your leg movement. So I'm just going to demonstrate that. So as I'm moving, even if I'm not holding it, it will move by itself.
Yeah,
Yes.
it's done by the sensor.
Yeah, so it's done by the sensors in the leg. Now it's measuring my movement as I'm moving, and it's gonna follow it. Okay. So as I said, another part of it, you can even use the force sensors that are installed here also to navigate it and move it around. Okay. Yes. We'll take some.
So what are the four sensors that you are navigating here?
The force sensors, pressure sensors.
The pressure sensors, okay. So it's able to direct as to which direction you're going to.
Another thing that I missed, so it can either be in standing mode, or if you want to sit, you can even sit. Let me see if I can get it. Okay, so. Okay, let's see. I need to be aligned. So, yeah. So now I'm just using the sensors on my legs to move it. Slow, but yeah. I think also the battery maybe, but yeah.
Yes, we have a question.
I just want to understand the role of this equipment in the rehabilitation process. How does it actually assist in the rehabilitation? Because I can see this one is a wheelchair and it's for mobility. Like I need to move, I can't move, I'll use the wheelchair. But this one, I still need to utilize my legs through the sensors to move the machine. So I just really want to understand its role.
That's right. So if you can just give us insight there. Yes, please. Can you please share with us your name and which institution you're from?
Okay, my name is Dr. Mulapani Chu. I'm the public health medicine specialist. I'm from Tembisa Hospital.
Thank you so much. A question?
Okay. The role of it, as you said, it's a rehabilitation device. So from measuring the movement, normally when you have your passive gait trainers, whether it be the weight body system or your rollators, where you physically need to hold on them, you need to use some upper body strength in order to hold on it as they learn how to walk. Sometimes they even have the parallel bars. They'll use them also to hold on them as they balance and move their legs. So in this case, you don't really need to balance on the device. It will measure your own movement and use that in order to navigate. So your what do they call it? Now I'm missing this one. Your weight will then be weighed on the device itself, but the movement of the device will be controlled by your legs. So as it's measuring also, it's not just controlling the device, but as it's measuring your movement, your gait movement, in turn, it will give the therapist a profile of how your movement has been. And from that profile, it can use it to map against how your actual profile is supposed to be in order to better assist you to move.
Fantastic. Any other questions from the floor? Any closing remarks from you?
I just want to thank you for joining us. And yes, augmented birth devices are all part of Augmented Mobility, which is a startup here at TUT. Thank you.
Thank you so much. And this is your startup. Your startup. Okay, fantastic. Thank you so much. All right. Shall we move on? Good morning, sir. Yes. Good morning. Can you please tell us your name and where you're from?
Hello, my name is Tian du Plessis, and I'm here from TUT. Currently doing my master's on this project that you see here. It's an active hand exoskeleton, and we want to try and interface it with a brain-computer interface, so it can detect your intentions of the user, and then apply that intention to the hand exoskeleton at the right time. So that's the basic operation of what we're trying to accomplish here. I just quickly want to also show you the basic architecture of what we're trying to do. So the hand is said to be one of the most complex structures in the human body. Okay, due to it has 21 degrees of freedom for the whole hand, 4 degrees of freedom for each finger, and to have an exoskeleton to actively actuate all of those degrees of freedom is very complicated. So this innovation is. The exoskeleton is a mixture between soft and rigid components. Okay, so rigid components restrict certain joint movements. So the soft part of the exoskeleton is basically it conforms to the hand or to the finger, and it uses the user's skeleton to as a structure to actuate the finger. So for the actuator, it's placed remotely for the user to be more mobile. So that's the basic aim for this project as well, to have mobility. So for instance, let's say the user's in the kitchen, so they can use the device in the kitchen. And this is mainly for patients who have hand disabilities or impaired hands. So there's the different, as you can see, the different elements of what a hand exoskeleton consists of, which is basically your actuation, your power transmission, your control, and your sensing. So just also want to show you a live demo because this live demo is not actually working at the moment. So I've made a SolidWorks demo. So also for the design process, I used kinematics of the finger. And then there you can see, that's the basic working principle. So the rigid is the red part, and the blue is the soft elements. So it's been actuated by cables, as we can see here in this demo. And this is the master's project for now. And then we're going to interface it with your brain-computer interface through this EEG cap, the electroencephalogram. So this senses the intention of the user, and then we use an existing BCI because another student already created the BCI. Then we interface it with that BCI, and as you can see here, we use this eMove to control the hand of the exoskeleton.
Wow. Fantastic. Is this a local innovation? Is this in-house? And
Yeah, I'm currently working at SARChi as well. So this is the innovation of using a hybrid solution to the problem and to see if it will carry the design forward for future.
fantastic. All right. Thank you so much. This is awesome innovations. Yes. Yes. Good morning to you, sir. Can you please introduce yourself and tell us where you're from and your contribution to the SARChi chair?
Okay, good morning, everyone. My name is Armand Duplessis, and as you can see at the top, we're from Siemens Digital Industries Software. So we're specifically from the software division, and we're kind of representing the industry today, right? So the software that we use is not experimental, not research-driven. It is stuff that's used in industry today, okay? So if you have cars that you're manufacturing at high volume, or shipbuilding, or electronics, or semiconductors, anything around the world that you can think of a product, our software is used and driven in the background to design these things. Where do we come in? Although Siemens produces their own products as well, we as the software division support manufacturing of industry. How do we do that? Well, we make it cheaper for startups like everyone here, all the different robotics and all the different stations that are here. If they want to have a quicker startup time, right? Think about starting your own manufacturing company. How costly is that, right? So we virtually commission products from cradle to grave. Okay, so if you want to design your product before you even make it, and you want to know what it's going to be like to manufacture it before you even have a manufacturing facility, we have the software that can help you and support you in that. If you want to go over and you want to make your own app, if you have IoT data, we have the full stack. We can pull up your data into the cloud, and we can start pushing out your app into the industry. So really, we're here to support all the other people that are here. If they have questions about, listen, this is our startup, this is the research we're doing, how can we connect with industry, right? We're that bridge between the research and the industry, and we'll help them cross over. That's what we do.
Well, fantastic. So for all your support in your systems, in terms of developing whatever it is that you want to, these are the supports that will come through for you. Thank you so much. Yes.
Just a word of appreciation to Siemens. My name is Vati Papuzamkaka, the Deputy Vice Chancellor for Research. There's a lot that Siemens is doing to our university. So, so over and above you being in here to demonstrate, but the world out there needs to understand that Siemens is among the companies that is contributing to our innovation at the university. Yeah.
Ladies and gentlemen, a word of gratitude from the Deputy Vice Chancellor. We continue with our exhibitions. A very good morning to you, sir. Can you please introduce yourself and please tell us which institution you come from and what your innovation is contributing to the SARChi chair in enabled environment and assisted living. Thank you so much.
Okay, hi everyone. My name is Dwayne Engelbracht. I'm a PhD student at TUT, also at SARChi in the enabled living and assistive living. I'm going to show you first the project I did my master's on. It's on collaborative robotics, ground robots that avoid one another, and it's based on virtual impedance. And then we'll get to this side and we'll just show you a static robot and how it's, what it does and what it's based on. So first of all, I would like you to meet our robot called Lumo. Maybe you can hold the mic next to him. He can talk as well.
Hi, my name is Lumo. Robots are very smart. Whoa! Almost as smart as my programmer. He talks a lot. Enjoy the show. Whoa.
I was not sure. Can we just do it again?
Hi, my name is Lumo. Robots are very smart. Whoa! Almost as smart as my programmer. He talks a lot. Enjoy the show.
Okay, I'll quickly just demo the back one that does avoiding. So it's just going to move and avoid.
Thank you. Do you want to maybe share with us?
Okay, so it kind of just looked like it avoided something, but what really happened in the algorithm is that it plans a path from the beginning to the goal point, the ideal path, not knowing that there might be objects or obstacles. And as it moves, it detected the object, and at that moment, it had to replan and avoid it. And obstacle generates a repulsive force, and we saw that the robot got pushed away a little bit and then moved back to the goal. So the goal also, or the goal point, has this attractive force that pulls the robot towards the goal. Yeah, so that is it.
Fantastic. Thank you so much. Excited to have met Lumo. Yes, do you want to perhaps show us what you have on display here?
Then continuing with collaborative robotics, the main aim is eventually to have mobile robots, all types of robots, collaborate with static robots in a artificial intelligence type of system. So right now, this is independent. It's not working with those, but it's just a display. It's built on reinforced learning. So the robot learns as it moves. Sorry. And we are just showing how gentle it can pick up objects so that it's safe environment for robots and humans to work in the same environment.
So this is a real egg, right?
No, it's not a real egg. It is a rubber one, but it does press. It can press not soft enough to not break it. But for today, we just brought a rubber one just to be safe.
Okay, fantastic. Thank you so much. Any other information you'd like to share with us? Okay, fantastic. Thank you so much. Yes, do we have a question? Yes. Can you please introduce yourself and from which institution you're from before you ask the question? Thank you.
Thank you, Ria. I'm Naledi Ntite. I'm the Deputy Director for Research and Innovation here at TUT. I want my colleague to just touch on the role of the robots during the pandemic, because I'm just thinking that we can use that to hand over sanitations and masks without human interaction.
Yes, that can be done. That's a good idea. Even we are planning to do the research where there's a hand at the end, and it's a hand that can hand things to humans and identify your hand to place it in your hand or even take it out of your hand. So that's still part of the research. This is just step one.
Fantastic. Thank you so much. Any other comments, questions from the floor? We move on. Good morning, sir. Can you please introduce yourself and where you're from and what is your contribution to the enabled environment and assistive living? Thank you.
Thank you. Good morning. My name is Gustav Udahemuka. I'm doing a postdoc in the Faculty of Engineering. My project that I'm going to present is for the emotion recognition, and is under the research chair for enabled environment and the assistive living. Emotion, given that is a non-verbal communication, it does enhance our communication, the communication we have between each other. It does add to the verbal communication. And you find by detecting the emotion, we can be able to use it, for example, for healthcare and also for other fields. But for this project is for stroke rehabilitation. It will be used to be able to rehabilitate someone who had stroke. And given that we can have different phases during the rehabilitation, we can be able to see the emotions, how the emotions changes over time. Yes, that's fine.
Yes. Yes.
Add something. Yeah, I'm Prof. Karim, the SARChi chair in Enabled Environment. We work together with Gustav. He's a very bright guy. The idea is to use emotion for different kind of application. Emotion, we are building technology out of human need. We build technology and we think that technology is good for human. You need to build technology with human in mind. So you have to look what impact this technology has on human happiness and well-being. That's why we bring emotion into place. So we do rehabilitation, but the application is for different kind. For education, for human relation in professional space, for when you get to learn about your own emotion, you can build system and robot can be empathy. They do it like a woman, they do it for you and not without you. So that is the kind of application we are looking to. So Gustav will show you the first phase where the system is able to recognize the emotion in real time.
Yeah, what we did develop. Yes. Yeah, what we did develop is here we have a camera. Now we can be able to detect emotion from the face. But we can also do the detection from speech and also the physiological signals. But for this case, we have a camera. When you stand in front, it's going to detect your face. Then it's going to show you which emotion you have. it will show you the emotion you have on the application. Yes, yes, you can test. Okay. Okay. Yeah, yeah. Okay, okay, okay.
Angry.
Okay. Yeah. Okay, that one. Yeah, happy.
We are working on this. You identify someone and you track that person from the other person. The system for now is cut in your at least.
Yeah. Yeah. Yeah, yeah, it's only showing one person, the first one. Thank you.
Yes. Okay. Thank you very much for this innovation. Just one question. Once you've captured the emotion, how are you going to use that in rehabilitation in a stroke patient?
Go.
Yes, we use it for rehabilitation. Given, for example, a person who had stroke, we want the person to regain some senses. Then when we check, we can be able to check the different emotions the person has. Then from there, when we track it, if we track the emotion of that person, we can from there know the progress of healing. Let's say how is the person getting healed. And if the person might, for example, stay on let's say one emotion and there's no changes, in that case, you might say that there's no progress. It help us to find the progress during the rehabilitation of a given person. It's more the progress, how is the progress? Because it's more for mental health, the mental side of the person.
Oh, fantastic. So, yes.
Yeah, it is okay. Yeah. There is two research activity that we are doing. So the fact that you measure the emotional state when you do rehabilitation exercises, you see if that exercise is done in the right way. So it depends on each person. What you do, maybe it's not adapted to one person to another person. It may differ. So you have to adapt the strategy of rehabilitation to minimize the time of rehabilitation. So it's from therapy point of view, based on measurement of level of emotion and during the exercise, your activity. We do human activity recognition as well. So you have a big capacity to identify the activity that humans are doing and the emotion state. We do also more complicated research on psychology. Dr. Etienne Jalong from France is here. He's a psychologist. We worked on dynamic of emotion expressed. People that suffer, they have problem for education, for learning, or they have problem with. We are looking to modeling this capacity, this emotion in the human, so you are able to let them give the best of them, to learn better, to master their emotional state. So that's what we are trying to do. So the emotion is too complicated. And the last level is you get to emotion, to get robots that are emotionally inclined, that are able to recognize your emotion, so to adapt to your need. We look to dementia. It's very important for people that suffer dementia, but also in your daily life. If you have a robot that talks to you, he see that you are sad. He knows what to play to do for you when you are in some emotional state. This is really helpful to get to this empathic robotics, robot that can learn your emotion and can adapt to your emotion. Thank you. Thank you.
Fantastic. There we have it, a robotic that has mastered emotional intelligence. Another question on the floor. Please introduce yourself and which institution you're from before you ask us your question. Thank you.
I'm Dr. Mlelekeng Situnsa. I'm a clinical psychologist, actually. I'm from Tembisa Hospital. Yes. So I think I'm just curious as to whether this could assist, people with autism and Asperger's who don't often demonstrate a lot of social emotions. Would that assist with that? Or those patients with traumatic brain injuries that have been affected?
Yes, 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 I said the project or the product. We also help, people with different mental illness, such as autism, and that again is going to be a progress. Is how it will help to check the progress during that, let's say, rehabilitation or during any therapeutic procedure. But it can also again, and also help for, even if it's not just to check the progress, you can be able to assess, and see what we can do to a particular patient, given maybe it's not easy to extract the emotion he has, but using let's say this application, you can be able to extract that emotion and be able to use it during the therapeutic procedure.
Just on that point, because let me just add one point. You are talking about autism. Okay, when you get young people that suffer autism, and the level of autism depends from one kid to another. You have this sociability problem. They cannot get in group, or their lecturing process is very slow, or they don't get to the group. So what we do, that's what we are doing with Dr. Ethan John. If we have the capacity to play pedagogical tool, to build a pedagogical tool that it's a serious game. You play that in a group, and you do action in a story that you are playing that generate emotional state. So you get the people to learn how to get to the group, how to learn with the group, how to learn differently, and how to manage their level of disability, like autism or other level of disability. So your capacity in doing in conjunction applications that are dedicated to professional use or education, or a group of people that have some psychological problem that you want to solve, you define tools that are a level that elevate or the level of emotion, and you analyze that level of emotion to get back and to get them live with that when they have a lot of anger, violence, and whatever they suffer, drug addict, or you can work on that level of emotion to get them accept their state in society. That's what we are trying to do. Okay, thank you. Please.
Thank you. Just a follow-up question. I'm just interested in the mechanics behind the measuring of the emotion. Can you explain to us how that is done? The mechanics behind.
Yes, the mechanics behind detecting the emotion.
Yes. For example, for the facial emotion, there are different points that we can have from the faces. Now, from those different points that I can also call it features, those features will be able to tell us if this person is happy. But it will be, if you use only facial, again, we might find some more false detection. Someone might be, for example, smiling, and you might think is okay. The application can say that the person is happy, but what we want is to do a multimodal where we do not use only the face, and also use the speech, and also the physiological signal data, so that we can be able to combine all of them to be able to extract the emotion a given person has. But using only face, it's going to be only some features, that we detect from the face. For example, if someone is smiling, the application will identify that as a happy emotion. Yeah, it's the feature we detect from the face for this case. Thank you. Thank you.
Thank you so much, ladies and gentlemen. Let's move on. The exhibitors will be with us throughout the day, so do visit their stands. Very good morning to you, sir. Can you please tell us your name and where you're from and how your innovation and research is contributing to the SARChi? Thank you.
Thank you. My name is Sam Magwazankuta. I'm from IFM Electronic. It's a German-based company. And the reason why we're here is that most of the equipment that you see here is currently being used by the institution in their labs. In the heart of the business strategy of IFM is innovation. And what you see there, it's innovation solutions that have been manufactured by our company, IFM Electronic, which is based in Germany. And basically, we're trying to bridge the gap. You find a situation that in the industry that we deal with is the motor industry. You've got the BMW right here in Pretoria. You've got the Nissan. You've got Coca-Cola. We also deal with the mining industry, the Anglos and the likes. Now you've got that gap between we've pushed so much innovation on into that market, and then there's a back. And you find that the institution are not really geared up to meet those innovations when they get out to the student. So that's why now we've realized that it is very good for us to team up with institutions like TUT and definitely bring the technology here. All right, so let's start here. So on the screen here, it's our IoT, Internet of Things software package that has been developed. And it's a web-based solution. So it's not an application that needs to be installed. If you've got a web browser, you can definitely pull the information. This is an application where we've used a simple demo units. This is a demo tank where you'll find in any process, whether it's in a brewery process, cool drink process, whether it's pressure sensors, temperature sensors, and flow sensors and the likes. And we're pulling that information into a web browser platform, which can be loaded onto your server and via internet connect to it. That is simply then your cloud-based solution. You've got your Internet of Things already there. We've got also a valve here that will also protect. So as you can see there in the display, we've got the valve position, we've got the valve status, we've got a runtime counter for how long the valve has been open. On this side, we've got basically our condition monitoring solution. This is for machine protection. And basically another study of an institution which is derived from, the solution is derived from signal processing. We've got a raw value here that has been, we're getting from these sensors. And from here, then we translate that to something that a human being can understand. Of course, the students here can definitely analyze the spectrum, but you find that people are unable to do that. So this is something that then we offer then. This side, I will definitely hand over then to my colleague, Somutambo.
Oh, yes, my name is Som Tambo, and I work for IFM. Yeah, so what we have here, this site is typically what you'll find in food industries. So what is important in today when it comes to automation is simplicity, the speed, as well as smart sensors that can be used. And these sensors, they mainly are important for production, for the food that is being produced. We want to check the quality of that food. So basically that's what we displaying today. So these sensors, they're complementing what you will know as Internet of Things. They call it IoT, others they say Industry 4.0, but it's all start from the sensor level. Okay, so what we have, this side, we're showing that, okay, it doesn't matter what system you can have on the higher level, this sensor, they can able to push the data from that system. A typical example for this will be an application where you have something like this. This can be a long conveyor line. Let us say maybe you're making a Danone product, juice product, different types of material. You want to reject some certain material if they're not according to your standard. So you want, basically what will happen in the past, you'll lose a lot of sensors for those type of application. But today we have IoT sensors. We call them IO-Link. And these IO-Link sensors, they are very smart. They can able to do more than just one functionality. All right. So I have a demonstration here that I would like to show you guys. And let me just quickly get this running as well. Okay, beautiful. So we said, so we're showcasing this because TUT is using this, okay? That Excel, we're all familiar with Excel, right? Finance people, they like it. So what we're doing is we're taking the information from industry, we're pushing to Excel. So as at moment it runs, if I take this product, let us say this is a good product that you want to see on our production, and then I put it here. And then you can see that it tells me there on the Excel that yes, there is a product that's available on the Excel. So it's just one sensor that is doing everything. So this sensor is giving me the distance, and as you see at the background, that value that you see there, it's the same value that you'll see there on Excel. Because you are next to me, you can actually start this process by just touching that light on top, because the light is telling us that there is a product. So you can touch it. There you go. You leave it. No, it's fine. Today, you don't need to be hard. You just touch and leave. So tell us that the product is there. So this is basically a good product. You can see it here. We can count it on Excel. We can see it. And if I remove it, I can put a new product. This is a new product. And this one, we just want to check it. So it cuts it. And it rejects that one because that one is not a good product. So it's actually one sensor that looks at everything. So basically that's it is. And then this information you can able to do the same thing using your phone. I can just stop the system. It resets there as you see. And then I put, this is the phone. So I've got the configuration here. It's a simple configuration. So the system is ready. And then I can start it here. And then it runs. And then it stops. Okay, so it's all integrated to the devices that we use. You get it everywhere. Okay, thank you.
Thank you so much. We move on. Yes, over to you.
Just a word of gratitude again to our industry partners for ensuring that we're having future-ready graduates. We are so proud to have you as our partners, because our mission is to ensure that when we produce the students, they are ready. And that's what you are contributing to. Thank you.
Thank you so much. A word of gratitude from the Deputy Vice Chancellor. Thank you. Sir, can you quickly introduce yourself and quickly tell us about your innovation and research? Thank you.
Okay, thank you. My name is Prosper Sotenga. I'm a PhD student and a staff member of Electrical Engineering Department. So basically what we do here is we work on IoT. So we basically interconnect. At some point in time, all the things that you've seen around will have to form one ecosystem. They need to be interconnected. So we deal with the network infrastructure, the network's protocols and all of that that enabled all these things to be connected. Applications of such IoT basically include like your agricultural monitoring, your smart metering, industrial logistics and transportation and all of that. So one of the main applications that we also deal, that we focus on is your smart campus. And based on that, we've developed a prototype. As you can see here, it's a very miniaturized device, which was built, designed and built in-house. So this is able to actually provide digital services or smart services for students. You can authenticate students at the gate. You can authenticate students for printing. You can provide access, and you can also locate students, track them. So currently what we've done is we've been able to develop an algorithm that is able to track students within a smart campus environment. So as you can see, we have 3 sensors mounted here. In fact, it can go for a long distance of about 1 kilometer, depending on the power level. So this mobile node, as you see here, is communicating with all these 3 nodes in order to get the range and to estimate the location. It's quite a complex localization process. So most existing approaches try to use your cell phones which have more computing capabilities. However, we are able to do that on a smaller node. On the other side, also, we have Wi-Fi Halo. Wi-Fi Halo is an improvement of the basic or the classical Wi-Fi that we have. If you look at the Wi-Fi routers that you have at home, they can only support about 64, 65 devices. But in terms of IoT, we are going to have a massive number of devices that need to be connected to the internet. So Wi-Fi Halo is one of the standards that has been designed to be able to support about 8,000 devices. So there's a rush amongst industry partners to actually develop this standard so that it can basically accommodate 8,000 devices. So we've worked, we partnered with Comsys in France, where we've managed to implement the physical layer component of the Wi-Fi Halo in order to support 8,000 devices. Thank you.
Thank you so much. Any inputs? Yes?
Adding few things. We develop research within this IoT environment, and there is different technology. You have the one that was presented, Halo Wi-Fi, but we work also on narrowband, which is close to cellular network with telecom and other operator. So our objective is to build brick of technology, component of technology that makes the difference. So if you want to handle massive number of devices with an industrial environment, you need the reliability, you need critical communication. So that's what we manage. So when Sutenga was talking about this physical layer, there's a thousand of code at the silicium level that you have to design. It's a chipset that you target to design. So it's complex system. We do it with the French company since years now, and with the support of Telcom and Nokia in the context of Center of Excellence, and with the support of the NRF for the chair. Thank you.
Thank you so much. Fantastic. We have had the opportunity to get the showcase of the research and innovation from the exhibitors. I want to encourage you to come visit their exhibition stands throughout the seminars, during the breaks. Thank you so much. Yes. Ladies and gentlemen, an announcement that you can grab yourself some coffee, grab yourself something to rejuvenate your energy levels. We will resume the program at 10:30. If you can just make yourself your way back, 30, we will resume at 10:30. Thank you so much.
says, it ain't anything to do. All I just long like together. Just got nothing to do. It seems it was all the way. 'Cause now all I have is pain. Thinking why I tried so hard. And now you just disregard the end. Thinking why I tried so hard, and now you just disregard the
Ladies and gentlemen, we will start with the program in 5 minutes' time. I'd like to encourage you to conclude your refreshment and make yourselves to your seats. Get settled. We will be starting in 5 minutes' time. Thank you so much. You, Ladies and gentlemen, please make your way to your seats. We are about to begin. I encourage you to make your way to your seats. We are about to begin. Once again, I'd like to encourage you to please take your seats. We are about to begin. Please take your seats. We will begin the program shortly. Thank you very much. A very good morning to all of you. I welcome you all, esteemed guests and delegates, to the DSI NRF SARChi Chair in the Enabled Environment and Assistive Living Research and Innovation Seminar. This is a hybrid seminar, and so I'd like to welcome those who are joining us online. Welcome. In this hybrid seminar, we will engage and be enlightened on the research and innovation in technologies and systems that assist in navigating the technology that is focused in driving innovation for sustainable development. And so I welcome you. Without any further waste of time, I'd like to call upon to the stage the Deputy Vice Chancellor of Research, Innovation and Engagement from Tshwane University of Technology, ladies and gentlemen, Dr. Vatiswa Babuzamkaga, to come and do the welcome and introduction. Over to you, Doctor. Thank you.
Sanbonan, Dumelang, Abshen, Goeiemorgen, good morning. Good morning to the colleagues online as well, the program director, the vice chancellor, and the principal of our university, the Tshwane University of Technology, Professor Lawrence van Steden, the ambassador of France to South Africa, His Excellency Aurélien Lachevalier, the Department of Health, and the NRF colleagues in our midst today, distinguished guests, as well as Mr. Matimba, who is representing the presidency. The representation from academia and industry, both in South Africa and in France, TUT management and staff, student leadership, and students at large, good morning. Today is a day in which we as Tshwane University of Technology celebrate the rich bilateral collaborations that exist between South Africa and France. The vibrant collaboration has made tremendous contributions to human capital development and technology transfer, which is evident in today's event. Today, we recognize how such interventions have made a tremendous impact on the lives of many students and provided them with the opportunity to have a truly international experience in their training. Through the collaboration, many students have gone on to become champions in industry. They have become established researchers in academia and in industry, which can be testified by one of our very own joint doctorate alumni, Dr. Emmanuel Kalunga, who will be doing a presentation later today. Another example of the impact of the program is Ms. Chulufelo Modise, a co-founder of the startup Augmented Mobility, who is present today at the seminar and did a great work in the morning when we're doing the demonstrations. She also had an opportunity to spend time in France as part of her master's studies, and currently she is busy with her doctorate studies. The countless success stories that could be showcased demonstrate the immeasurable impact that the collaboration between South Africa and France has had on these individuals through the SARChi program. And the TUT is proud to host and its various collaborations, both in South Africa and in France. For those who do not know SARChi program, the SARChi is the French-South African Institute of Technology. Ladies and gentlemen, today we further celebrate the great work done by our research chair in enabled environment and assistive living, led by Professor Karim Dujar. Today, nearly 7.5%, which is about 3 million people of the South African population aged 5 years and older, account for people living with disabilities. This area of research has a tremendous societal impact on the lives of people, since many people with disabilities continue to experience a lack of adequate health and basic education and experience economic isolation with very little prospects of securing employment. The Tshwane University of Technology has a vision of being the people's university that makes knowledge work. One of the pillars that supports the institutional strategy in our university is to conduct impactful research, innovation, engagement, and technology transfer to foster growth, development, and sustainability. The South African Research Chair on Enabled Environments and for assisted living at Tshwane University of Technology aims to contribute to the area of assistive living for people with varying levels of disability and for the elderly. The research areas and application domains cover multidisciplinary topics and domains such as complex and network systems, control mechatronics, and robotic systems design, machine learning and artificial intelligence, as well as wireless and communications. As we celebrate National Disability Awareness Month, we are honored to host today's event to highlight the importance of developing solutions to address the challenges faced by this marginalized sector of community to bring a sense of normalcy to them. As I welcome you this morning, I would like us to reflect on some key highlights in relation to SARChi and the research chair that has achieved over the past 15 years. I would like you to listen very attentively. Looking at the contribution to human capacity development through a global training program, the SARChi has contributed to the graduations of 140 collaborative masters. I thought you would clap hands. Just to explain there, pause, collaborative masters is a for the collaborative masters program, ladies and gentlemen. Our students complete requirements on both sides, meaning the subjects for the French part and the master's dissertation on the South African side. Over and above the 140 collaborative masters, we also have 120 masters, not collaborative now, 120 masters. We also have 40 doctorates and 21 joint doctorates. These doctorates are done together with the French partners. 10 staff members completed joint doctorates, 9 staff members completed collaborative masters. Now, looking at the contribution to joint research output between the partners, ladies and gentlemen, over 1,300 research outputs have been delivered over the last 15 years. Looking at the contribution now to innovation, isn't this awesome? 9 patents, augmented mobility startup, partnerships with industrial and research funding agencies, the Department of Science and Innovation, as well as the National Research Foundation funding of 2.15 million per annum since 2016. Can you clap hands for them? Bursary and staff mobility support amounting to 2.5 million rand per annum from the National Research Foundation since 2017. Funding from industrial partners Telkom and Nokia on the Center of Excellence project of nearly 5 million over the last 10 years. Funding from AFD of 1 million rand. Funding from the CSIR of 500,000 rand per annum since 2016. Student bursary support from the French universities UPEC and UPSE for support of TUT students' stay in France. Involvement in various European collaboration projects for mobility on the Erasmus programs with various partners in France. Funding from the French Embassy for student bursaries, mobility of staff and infrastructure that has enabled various exchange of staff and students to France. The combined contribution that have been made to the program by the various stakeholders involved with the program has been a big support in ensuring the richness of collaborations and the outcomes achieved. However, there is more to be achieved. As I close, colleagues, I would like to quote an African proverb which says, if you want to run fast, run alone. But if you want to run far, run together. Your coming here is celebrated and would like to invite you to strategically partner with us so that we advance the research agenda through the entrepreneurial approach to education, which will contribute to the alleviation of the high unemployment burden, inequality, and poverty in our beautiful country. Let us run together, colleagues, so that we run far. We are indeed the ones we have been waiting for. Let us chart the new territories and take our country from glory to glory. With God, it is possible. In my language, program director say, halala TUT, halala. Halala TUT, halala. Indeed, amaqobokazana ngalala endleleni ngabe kunyembelekile. Thank you so much.
Thank you so much, Dr. Batiswa Papuzamkanga, the Deputy Vice Chancellor of Tshwane University of Technology. Thank you so much. Once again, my name is Ria Mujapelo. I am your program anchor, and I'm quite delighted to be anchoring in this seminar. Just a few announcements before we proceed with the program. There is one exit there, and if you make your way to the exit, straight on your left, we've got the male toilets, and on the right, we've got the female toilets. I just want to encourage you also to observe the COVID-19 protocol, that we keep our masks on, and also we keep our social distance. I'd also like to encourage you to familiarize yourself with the program, also that you take note that we will have breaks in between the program. And during those breaks, you're more than welcome to visit the exhibition stands, and also just to interact with the exhibitors and get more information on what they are exhibiting this day. Without any further waste of time, I'd like to call Professor Lawrence van Staden, the Vice Chancellor and Principal of Tshwane University of Technology, to enlighten us on the French-South African collaboration in the digital era. Over to you, Professor Lawrence van Staden. Thank you so much.
Bonjour, Likai, Towela, Avugeni, Molweni, Sawona, Kunjani, Dimajoroni, Goeiemorgen, good morning. We are the People's University, therefore we need to cover as many languages as possible. On behalf of the Tshwane University of Technology, I would like to welcome distinguished guests, various stakeholders from academia and industry, our very important visitors from France, staff and alumni present to the 2021 Enabled Environment and Assisting Living SARChi Chair Research and Innovation Seminar. I would like in particular to welcome the Ambassador of France to South Africa, His Excellency Aurélie Levalchali. The Tshwane University of Technology had the privilege of hosting a vibrant collaboration program between France and South Africa, which has from its early days played a critical role in significant human capacity development, development of research, and very important technology transfer, and the development of vibrant international collaboration. This can clearly be attested by the number of students trained over the last 25 years. I think this is requiring a hand here. This is a vibrant strategic partnership that existed 25 years. And for those who don't know, initially, it was co-signed by our former president, the first president of the Democratic South Africa, Mr. Madiba. He was a co-signing of this very important agreement. So the contributions made to staff development, the research outputs generated, and the extent of contributions made to technology transfer. The recent state visit of the French President Macron to South Africa highlighted the importance of academic and scientific cooperation between South Africa and France, which saw a new agreement on cooperation on science, technology, and academic cooperation being signed. This demonstrates the importance of the academic cooperation, which is at the heart of these bilateral agreements. TUT is grateful for the valuable contributions made by the two governments towards the collaborations and the SARChi program at the Tshwane University of Technology. As South Africa celebrates National Disability Rights Awareness Month between the 3rd of November and the 3rd of December, with National Disability Rights Awareness Day celebrated on the 3rd of December, it is important to take cognizance of the impact of persons with disabilities and to promote, to support them, the research. According to the World Bank, 1 billion people, or 15% of the world's population, experience some form of disability, with the prevalence of disability very much higher in the developing countries. 1/5 of the estimated global total, or between 110 million and 119 million people, experience significant disabilities. With a compounding of above with the COVID-19 pandemic, which continues to have wide-reaching impacts across the globe, it is important to note how persons with disabilities are uniquely impacted by the pandemic, including health, education, and obviously transport considerations. The Disability Awareness Month offers an opportunity for all of us to remove these barriers and further highlights the need to improve the quality of life of people with disabilities through concrete action. The showcase of research and innovation that is taking place today demonstrates how the intervention of technologies that include the convergence of 4IR technologies such as artificial intelligence, robotics, the Internet of Things, and cloud computing can all serve a platform to propose innovative solutions to improve the lives of people that suffer from various forms of disabilities. The SARChi TUT research team is currently working on a number of solutions that range from exoskeleton development to assist with the therapy of individuals who have suffered some form of disability. The development of assistive platforms such as active wheelchairs and walkers, the use of high computational platforms to provide assistance to detecting the impact of the emotional state of individuals using artificial intelligence. The development of massive IoT and cloud computing platforms to assist with data processing and evaluation dashboards. These technologies are highly directly being aimed at making an impact on the improvement of the daily lives of individuals that suffer from some form of disability with a sense of normalcy to their lives. The said work would not be possible without the valuable support received from various stakeholders. The support of the French Embassy and the French Ministry of Foreign Affairs, the Department of Science and Innovation, and the National Research Foundation, the various academic institutions involved in the collaboration, and obviously very important, the support of commerce and industry. TUT is grateful for the valuable contributions and support being received from the various stakeholders. I take this opportunity once again to thank His Excellency, the Ambassador of the French, for his support, the support of the various stakeholders and industry present, and the various speakers, both from South Africa and France. I look forward to an enriching research and innovation seminar and the potential of new, vibrant and strategic collaborations that will emerge from this visit. I thank you. Siyabonga, kiyaleboa, enkosi kakhulu. Umuntu ngabantu.
Thank you so much, Professor Staden. At this point, I'd like to call the French ambassador to South Africa to come and address the SARChi Chair in Enabled Environment and Assistive Living, Research and Innovation Seminar. Ladies and gentlemen, let us put together our hands for His Excellency Aurélien Le Chevalier. Thank you.
Thank you very much, Program Director. Sawubona. Good morning. Bonjour. Dear Vice Chancellor, Professor Lawrence Van Staden, dear Deputy Vice Chancellor, Dr. Papu Zamkraga, I hope the pronunciation is fine enough. Dear Mr. Lawrence Matemba, DDG Policy and Research Services at the Presidency, dear Professor Fuluflelo Nelwamondo, CEO of the National Research Foundation, dear Dr. Freddy Gongwana, DDG at the Department of Health, dear Dr. Yves Guénon, Chairman of the South Africa France Chamber of Commerce and Industry, dear Professor Karim Jouani, dear Professor François Rocari, Professor Yves Blanchard, dear professors, doctors, dear TUT community, distinguished guests, ladies and gentlemen, dear colleagues, dear friends. Thank you for inviting us to the opening of this international seminar and for organizing such a beautiful event and magnificent setup for today and tomorrow. And we are proud to be surrounded by the most esteemed personalities in ambient intelligence. I think our two previous speakers said it all about the philosophy and the objectives of this international seminar. And it's an honor to be part of it this morning. Initiated within the SARChi program and led by Professor Karim Jouani, the SARChi chair is already a success. I will just quote some impressive figures that our Deputy Vice Chancellor also mentioned. 40 postgraduate students, more than 140 papers in indexed journals, 6 patents, and 10 prototypes and technological artifacts. These are very impressive achievements indeed. The primary objective of the research chair is to link research and innovation to physical and cognitive assistance, so as to assist persons with disabilities and elderly persons. It will do so by identifying the most recent trends in assisted living and ambient intelligence, advanced robotics, artificial intelligence, as our Vice Chancellor said, as well as in the field of the Internet of Things and cloud computing. Your knowledge, your research, and your talks during this seminar today and tomorrow will enable a large part of disabled and elderly South Africans and beyond in Africa and the world to benefit from improved living conditions and greater access to daily activities. But before the seminar begins, we would like to express our heartfelt gratitude to all of you who sincerely committed to this event to make it a success. We would like to thank all our South African partners and all our SARChi partners for their commitment over the last 25 years. They have impacted and changed the course of lives of so many young people. I would like particularly to acknowledge the role of the Chamber of Commerce and Industry of Paris-Île-de-France, President Jean-Paul Vermès, Professor François Rocari, Professor Yves Blanchard, and all the colleagues and professors involved for their personal engagement. We would like to convey our deepest thanks to Professor Karim Jouani. Your focus, Professor, and commitment over the past 15 years are to be admired. By taking time to dedicate yourself to scientific partnerships between France and South Africa, you have been a shining example of the collaborative work that we value the most. We would like to give a special thank to the National Research Foundation of South Africa. By funding the SARChi chair, you have strengthened French and South African bonds in the fields of science and innovation. Your commitment to putting research and science at the service of the people sets an incredible example for everyone. We would like also to express our deepest gratitude, of course, to the Tshwane University of Technology, with whom we have long-standing links, notably through this SARChi program, and a long history of trust and friendship. Thank you for setting up such an exciting seminar, for welcoming the SARChi chair within your premises with open arms, and for being an integral part of the French-South African science diplomacy over decades. Vice Chancellor, Professor Lawrence van Steden, thank you for your unwavering support over the years. The lasting partnerships we have built and the bonds that unite us are outstanding. We look forward to seeing you in France, and we would be delighted to welcome you all soon as a token of our appreciation and friendship. I wish you all a productive and successful event. It's a long journey, and we will be at your side. Thank you very much.
Thank you so much to His Excellency, the Ambassador, the French Ambassador to South Africa. At this stage, I'd like to, in his absentia, acknowledge Professor Fulufelo Nelwamondo, the COO of NRF. And so on his behalf, I'd like to then hand over to the floor Dr. Gansen Pillay, the Deputy Chief Executive of RISA, who will then enlighten us on strategy on innovation and academia industry collaboration. Thank you. He is joining us online. Thank you.
Good morning, distinguished all. I'm not sure whether can you hear me? Okay.
Yes, we can hear you. We can hear you, Doctor.
Good morning, distinguished colleagues. It's a real pleasure and privilege to join you this morning. Celebrations and congratulations to all those who contributed to this fantastic achievement. Yesterday, when I was first to stand in, I was programmed, and this morning I put some thoughts together regarding the celebration. I've had the privilege of being associated with the SARChi program, falls under my purview for the last 12 years. We've had some really great moments with the SARChi program, especially our collaboration with the TUT and Sequence. I'm also human capital development. It's really stimulating to see that the objectives that we set out at the beginning are actually beginning to bear fruit 15 years later. So congratulations all round. This morning, I just wanted to take you through a very short journey on NRS approach. Through both the SARChi and Centers of Excellence linked grants over the past 5 years. A cumulative total of more than 8,184 peer-reviewed research articles in accredited and Web of Science journals, 637 book chapters, 138 books, 51 patents granted, and 104 technical reports or policy documents emanated from this investment. The current cohort of chairs leveraged over 2.8 billion from public-private partnerships to supplement these grants over at least the next 5 years. The SARChi funding instrument, and I think this relates very closely to the theme of today's meeting, is currently supporting a total number of 10 communities of practice, ranging from poverty and inequality, remediation of degraded land, control of malaria, marine spatial planning, biodiversity assessments as a form of social learning, developing indicators for innovation and inclusive industrialization, skills development for oil and gas exploration, and production, as well as social learning and sustainable development. Closer to home and closer to this program today, of those 257 SARChi chairs that I mentioned, 33 of these chairs across 13 South African institutions, of course, including the Shwana University of Technology, focus on academia-industry collaboration. These chairs conduct research aligned to the Sustainable Development Goal 9, which is industry, innovation, and infrastructure. Some of them also conduct research aligned to the bioeconomy grand challenge, namely bioeconomy industry and bioeconomy health innovation. The chairs have further alignment to the 7 MTSF priority areas, including a better African world, spatial integration, human settlements, and local government. Industry partner, of course, include a number of sectors, including water, waste, urban planning, health, etc. It's interesting to note that of these 33 chairs, 7 were recruited directly from industry or internationally, and 26 were recruited from South African institutions. If you look at the gender and demographic breakdown, it's something that we still have to work on. The 33 comprises 8 females and 25 males, and there are 17 Black and 16 white shareholders. I now want to take you to the National System of Innovation and look at how we are playing in this space. Now, the NSI is fostering South Africa's collective effort towards technological innovation. Of course, on one side, you've got academia, and on the other side, you've got industry. And the way the NRF is attempting to position itself in Vision 2030 and with Strategy 2025 is how do we actually advance what we would call a quadruple helix approach, bringing academia, industry, civil society, and government together for the common good of society. This year shows you actually the scales on which things are done and the reasons why we have chasms like the innovation chasm. The key point about this slide here is that you cannot have a successful partnership if there's no collaboration and if there is no mutual benefits. Those are the hallmarks. And if you look at the SARChi, the South African-French collaboration, the hallmark of that collaboration is one, it's based on trust. Second, based on mutual benefit. Thirdly, it's based on a value system. And fourthly, it's based on developing the next generation of researchers and students. So it is those value sets that actually determine how we move forward. And if we look at the South African landscape in a situational analysis, this is the downside is the lack of collaboration. And of course, the lack of collaboration has many unintended consequences and negative effects. So if you look at this schematic here, you could see some of the problems that we face within the NSI. Therefore, the NRF sees itself playing a catalytic role in bringing different sectors of society, of government, of academia, and industry together so that we can work towards a common good. Previously, the Department of Trade and Industry funded what was called the TUT program. There was a very successful program. Regrettably, the DTI has now terminated the program. Therefore, the NRF, in consultation with the Deputy Vice Chancellor's research, have identified the need to establish a focused academia industry collaborative program, hence the development of what is a draft strategy. So there are a number of barriers to collaboration. And one of the things that we have to do is to identify these barriers and then, of course, try and work towards alleviating or removing those barriers. Firstly, we have to create spaces where there's collaboration. And the Centers of Excellence is a good example of that, where you create a hub and spoke model where there's codependencies. People are also co-creating products and new knowledge. So I think it is a partnership model that is critical. We need to drive open innovation as the NRF. We need to encourage a culture of flexibility between academia and industry. For example, postdoctoral fellowships should also be tenable within the industry sectors. And I think that will lead to a richness of collaboration. Now, look at a strategy a draft strategy for academia industry collaboration. We found that there was a demand for innovative solutions that respond to socioeconomic challenges as well as opportunities. I've mentioned there's an increasing need for collaboration between industry. So what we have been developing at the NRF in terms of our strategy 2025 is a draft strategy that aims to accelerate the co-creation of knowledge, for one, the impact of knowledge products, and two, skills development supported by the NRF. When I sit back and reflect on the universities of technology And I have had the privilege of being in research-intensive universities, being a researcher there, as well as being at the University of Technology. But the one hallmark of the University of Technology, as Prof. Staden will readily tell you, is that they make work-ready graduates. Those students that come out of the University of Technology are able to get into the work stream immediately, unlike students that come out from university, where there has to be some lag time before you actually settle in. So the strategy here is also to provide direction to guide and position the NRF to play a prominent and facilitative role. So we're going to focus on 3 core areas. Skills development, of course, the human capital development. And this year, the focus will be on postgraduate students, postdoctoral fellows, and early career researchers, because the idea is to build the next generation of researchers. We have to promote joint research with industry for increased impact on society, and of course, collaborative networks as well with a number of other partners. Now, what you see in the schematic is the landscape, but the has to directly engage in this partnership and to increase this collaboration. Together, we can also mobilize resources, and we could avoid duplication of efforts as well. Now, if I look at the objectives of our draft strategy, we have some principles and we have some enablers. So the principle here is to bridge theory, practice, and demand-driven skills and research in specific themes funded by ourselves and our partners. We need to increase the uptake of our translational research is very much at the center of this collaboration. And then, of course, we have what we call the global knowledge partnerships, like our collaboration with the French. We have a number of other partners that we need to blend this with so that there could be seamless movement of researchers and postgrad students across borders and across industries globally. Now, enablers here is where at the national level, we can place candidates in local industry. At the international level, we can do the same. We have to customize some of the programs that's aligned with the new white paper on science, technology, and innovation and the decadal plan. And we need to make sure that there's alignment. Obviously, this requires resources. And we have to see how can we repurpose some of our budget towards establishing this collaboration and strengthening this collaboration. And of course, you need internship and placement programs. The second objective, of course, the principles here is once again collaborative research programs, and ensure that while you ensure excellence, ensure that there's engaged research with society, that the knowledge flows across all stakeholder sectors. And of course, we will have to focus on selected fields because we cannot drip feed across the spectrum, rather to make a focused investment in an area of strategic importance. And of course, we have a number of enablers that will help us realize this objective. Thirdly, the principles here once again relate to networking, the creation of platforms, the quest for strategic partnerships, and that we have to actively do through our strategic partnerships division. And of course, enablers here are actually what we have existing across the world in terms of a number of interactions. Here are some examples of the international relations that we have. These are just a few examples. There's MyTex Canada, where there's a combined investment of 15 million over 3 years. There's the SASL scholarships. And over here, we have our call 2020. We've already received 178 proposals that's currently being adjudicated. And of course, the outcomes of that will be known in December. Then, of course, we have the Science Granting Council Initiative, which is co-funded by DFID and the IDRC. And we are supporting 16 countries in sub-Saharan Africa. I am referring to this particular partnership on the African continent because South Africa cannot do this alone. We need to partner with our sister countries on the continent in order to have an African footprint and to have gravitas on the world stage when we enter those stages. Then, of course, we have the Global Research Council, and on that we have international consensus on industry collaboration. We've also put out a report at the GRC, which you see there, it's a reference, and it's on partnered research programs. So in conclusion, ladies and gentlemen, the NRF Academic Industry Strategy aims to accelerate the co-creation of knowledge for impact of knowledge product and skills development support. And secondly, this strategy provides direction to guide ourselves as to how best to play a prominent and facilitative role in promoting collaboration among all stakeholders in the NSI. As you can see, the SARChi program, which we are celebrating today, is merely an instrument that does all of this in terms of academia industry collaboration, in terms of development of new knowledge, in terms of development of new devices in this case here, and of course the skills and the ensuring the training of the next generation of researchers. I would like to thank you for your attention. I must say that as I exit the system after some 12 years at the NRF, I have a few months left, it is really reassuring to see events of this nature where you are celebrating success. It is the most responsible use of taxpayers' money, and the benefits of society cannot be overemphasized. So I'd like to thank all of you who are involved. May I just once again express my gratitude for the privilege and pleasure of sharing this morning with you. Thank you.
Thank you so much to Dr. Gansen Pillay for standing in for Professor Fulufelo Nelwamondo. At this stage, I'd like to call the Acting Deputy Director General for Hospital Services from the Department of Health, Dr. Freddie Kongwana, to come and address the SARChi Chair on the quality, patient care, and the fourth industrial revolution in the context of COVID-19 pandemic, the lessons learned. Ladies and gentlemen, let us put our hands together for Dr. Freddie Kongwana, the Acting Deputy Director General of Hospital Services from the Department of Health. Over to you.
Good morning, honorable members of the TUT, the Vice Chancellor, His Excellency the Ambassador of France, all the prominent members in this forum. We usually say all protocols observed. My title is Fourth IR and COVID-19 Lessons Learned. That is the issues of patient care. It has been a very difficult subject to engage with. How, being invited to this very prominent and very important meeting, how does one engage with yourself? All right. I guess I'm allowed to read here. You're right. Okay. He didn't show me which one to press. There's so much technology around, and I'm born before technology. And so I would prefer my colleague. The one that says next. All right. Thank you very much, sir. All right, the background is that we had Wuhan, Hubei province, China around November 2019. The novel coronavirus is detected on the 25th of January 2020, and estimated 75,000 people are found to be infected in Wuhan alone. The worldwide infection at the time was only 2,000 plus. 30 January 2020, the Director General of the WHO declared the coronavirus disease, COVID-19 or SARS-CoV-2, as a global public health emergency of international concern under the international regulation of 2005. And 11th of March 2020, the SARS-CoV-2 is declared a pandemic. And I think everything changed from that moment. The 5th of March 2020, the first case of COVID-19 confirmed by the NICD in South Africa The 38-year-old patient was admitted to Charlotte Macleger Johannesburg Academic Hospital. Everything changed in South Africa. On the 26th of March 2020, President Ramaphosa announced the first lockdown for the RSA for 21 days. Everything changed. The first wave of the COVID-19 pandemic hit South Africa from 8 June to 18 July 2020. That is a week 24 to 28 of 2020. We were hit by the first wave. Things changed. Currently, the country is on alert level 1 and posed the third wave of the COVID-19 pandemic. And 17 February 2021, the regional COVID-19 vaccination program was officially rolled out. So we've been living this turbulence of change. And looking at the issues of innovations and technology, as you see, I indicated patient care. I decided, let me welcome you to our space where I, as the acting DDG Hospital Services, I'm part of the crew that is piloting this big jumbo jet called the Gauteng Department of Health. We have to move towards the destination, which is the defeat of COVID-19. Currently, we're facing turbulence, which is called the fourth wave. And it is my duty and our duty as a crew to give confidence to yourselves as citizens of South Africa, as citizens of the world who are visiting South Africa, to say we're as ready as we can be. And what do we need to use is the fourth IR, is technology. What then happened from the impact of the lockdown? Utilization of the social media platform grew exponentially. Those of us who were technophobic, including myself, had no option but to join the space of the fourth IR and the next economic frontier. And I think this meeting, this conference, this celebration is about the utilization of technology to deal with healthcare services. Zoom, WhatsApp, TikTok, Twitter, Facebook, Blackboard, YouTube, etc., became the new norm of work and social interaction. Suddenly, we all are on these innovations. ICT innovation for the mitigation of the remote work and social distancing was expanded, and the combat of the COVID-19 was stimulated. I remember during the lockdown, as a healthcare worker, we had permission to travel. And I remember being on the N1 alone between Menlyn and Centurion. It was unusual, it was scary. I've never been on that M1 alone. I visited Menlyn, I was alone. It was scary. So the Gauteng Department of Health developed a COVID-19 bed management dashboard to monitor the admission of the COVID-19 infected patients. So we were forced to innovate. We were forced to use technology. And thirdly, the debates around the cost of data and expansion of fiber infrastructure became real. There were suddenly issues of data. Why is data expensive? Mobile companies in the RSA then reduced the cost of data to also encourage support homeschooling, including work from home. And then the 5G digital spectrum access was activated to combat economic stagnation as a result of the lockdowns and support economic activities in the context of the COVID-19 pandemic. So we have in the Gauteng Department of Health developed a dashboard that we use. It's like our dashboard, we're in this aeroplane, this jumbo jet, we are moving. In the healthcare space, TUT-TV, the NICD platform that captures the statistics and data for COVID-19 admissions, recovery, morbidity, and mortality was developed. The new language, TUT-TV. EVDS, Electronic Vaccination Data System, was established by the NDOH to capture the data and statistics for the COVID-19 vaccination program in the country. So everybody knows about EVDS now. You go to the mall, you go EVDS. Telegram, the social media platform, is used to manage the ambulance diversions in the Gauteng Department of Health in concert with the provincial EMS. So we had to use Telegram. There's a concept called ambulance diversions. When there is pressure in one hospital, we have to divert ambulance to another hospital. That is part of making sure that the quality of healthcare is sustained in the Gauteng Department of Health. The COVID-19 bed management dashboard, as I have repeated, was developed to assist monitor the availability of functional beds for the management of patients suffering from COVID-19. As you know that in the media, is that, do you have enough beds? Do you have enough beds? Do you have enough beds to make sure that we do not suffer, we do not expose our patients to unnecessary mortality or morbidity? WhatsApp is used extensively as a communication and management tool in the Gauteng Department of Health. We have more than 10 official WhatsApp platforms in the Gauteng Department of Health where we monitor in real time what is happening in the department. Emails still remain critical and essential in the communication of management decisions and support for the 81,000 employees of the Gauteng Department of Health. So this is the cohort that we need to manage the healthcare that is needed for 15 million population of the Gauteng Department of Care, 50 million population in Gauteng, so that we are able to continue to utilize about 18,000 beds that are available to the management of healthcare services in Gauteng. This is the DATCOF, and we use it every day to monitor public admissions and private admissions, and we have a total. We monitor your intensive care unit and high care, we monitor the general wards, we monitor the isolations, and also we monitor ICU. So this on a daily basis informs us in order to manage. We call it a strategic approach and informed decisions that is created by the demand. And this gives us an idea on a daily basis. Like this is on the 22nd of October, 2021. If you go down, it says in hospital patients in ICU and high care, we had a decrease of 7 patients from 317 to 310. General wards, we have a decrease of 16 patients from 119200 to 1176. So we daily monitor, we use innovation, we use technology, which means that this platform, the TUT, will have to really come up with over and above the innovation that exists to make sure that we become better at what we're doing currently. This is our bed management dashboard, which was innovated by the Gauteng Department of Health. Probably the guys who did that studied at TUT, I'm not sure, maybe I should check. And maybe they were funded by the collaboration with the French embassy. I'm not sure, it's possible. So this is what we developed. We currently have got 4,407 beds, functional beds in Gauteng Department of Health dedicated to healthcare of COVID-19. This is out of the 18,000 beds that we have in the Gauteng Department of Health. So as on the 21st of November, we had 1,209 patients admitted for COVID. And we had 3,198 beds available. So this we monitor on a daily basis. We separate between COVID positive patients who were 285 and patients under investigation, PUIs, who are 329. So we monitor that. It tells us that the functional high care beds available at the time is 436. The functional general beds available is 2622. And the functional ICU beds available is 140. Functional means that bed, we must have a doctor, a nurse, a cleaner, a porter, consumables, and technology. And this we monitor every day. If you look down, it tells us here. It tells us which hospitals have got pressure. Like on the 22nd, Mamelodi was more under pressure with 199 patients of COVID. So there is that desegregation of which hospital has got more pressure and what needs to be done on a daily basis. So this is our dashboard. We use it every day to navigate the space of COVID-19. And this is the utilization of technology to improve patient care, to be able to know what do we do next. So the fourth IR and psychosocial support for the healthcare workers, because that's one of the key things that came out, that mental health became a major big deal with COVID-19. We had suicides, we have fatigue, we have deaths, we're all affected. So the need for psychosocial support is very critical for the general wellness and mental health care of the healthcare workers on all fronts. The present impact of the COVID-19 pandemic has been immense. You have got colleagues dying, you have relatives dying. That has been very difficult. So thus a virtual counseling and psychotherapy support was established in the Gauteng Department of Health, supported by the Gauteng Provincial Government, and what we call the Zineka Care, means take care of yourself, employee health and wellness program, was made available and funded for all the provincial government employees. It was a 24/7 service available for the healthcare workers in the Gauteng Department. So you can call anytime and you will have counseling virtually. The Gauteng Department of Health also introduced a psychosocial support program called Employee Value Proposition. This program is supported by the private sector community social investment initiatives to appreciate and encourage the healthcare in the various Gauteng Department of Health facilities in the interest of patient care, patient safety, and improve staff morale. And this is an example of the bulletin that we send on a regular basis. Employee value proposition, how we enhance the employee's value proposition. So this is just an example that commitment and dedication of Sterkfontein nurses pay off. So we picked up Sterkfontein, there's a picture, appreciating the nurses at Sterkfontein, which is one of our major mental health care facilities in the province. So, and those are funded, those trophies and certificates are funded by the private healthcare sector. So it shows you the issues. One of the key issues was security of oxygen. In order to improve the quality of healthcare, we needed to have a supply and the security of oxygen. So we had daily meetings with all Gauteng Department of Health facilities with Afrox, who are our major oxygen supplier. Air Liquids only supplies one facility in Gauteng, which is the Anglo Ashanti. We conducted on MS teams to monitor the security of supply of oxygen in the Department of Health during the second and third wave of the pandemic. We intend to continue to execute the same approach during the fourth wave of the COVID-19 pandemic. We are currently still having meetings bi-weekly, so as to remain alert to the needs of the facilities for appropriate oxygen supply and management. That's one thing that we learned during that you need to manage oxygen, both the bulk tanks and the cylinders, which we realized they were very strategic. And a WhatsApp platform has also been established to communicate in real time and to effect intervention and solutions. This is an example of Carletonville Hospital bulk oxygen tank. If you can see, there's an ice, and if you don't have that, if you have that ice, the oxygen supply gets interrupted. So we get pictures on WhatsApp, and we get advice what to do to remove that ice. It's called de-icing. We have a picture of where it is, and we would advise just use simple tap water. Don't use your hammer, don't use your stick, simple tap water, because that ice makes the production of the liquid oxygen into air, into gas, disrupted. So we have to make sure that is removed on a daily basis. And this is what happens in a WhatsApp group. When guys didn't know what to do, they would send and we'd advise what to do. So there's a utilization of technology and the fourth IR. And we need to make sure that this is supplied on a regular basis. Collaborations came out very quickly, that the engagement with the private health groups in Gauteng province is happening on an ad hoc basis. So we have a meeting on an ad hoc basis with the private health sector. However, the exchange of information and data is happening on a constant basis as coordinated by NICD on .gov and EVDS. The COVID-19 vaccination program is also enhanced with the private sector, and that is why we want to have more than 70% of the population vaccinated and to achieve herd immunity in Gauteng. Communication of the truth based on science and research in order to combat the fake news around the COVID-19 pandemic has also been groundbreaking. So we need this innovation to make sure that we combat fake news. The support of the Solidarity Fund and other benevolent and critical stakeholders in the refurbishment of the CM jar and the donation of healthcare technology remain iconic and remarkable in the combat of the pandemic. The provincial government and the NDOH, the National Department of Health, are key facilitators and custodians of local and international collaboration in the context of COVID-19 and service recovery plans. The WHO is one of the collaborators. South African Defence Force, the NPO and NGOs, for example, the Rotary Clubs, VES RHI, Oram Institute, Doctors Without Borders from France, Gift of the Givers, have confirmed that partnerships and collaborations are very important in the combat of COVID-19 pandemic. This is one of the dashboards you use to know what happens with the private sector. You can see Netcare is the biggest. So it helps us to understand. So this is the use of technology also in making sure that we have care in the department. So in conclusion, these are the lessons learned, that science, research, and evidence-based approach is important in the combat of the COVID-19 pandemic. We cannot use hearsay, we cannot use social media. However, that the social media platforms are influential and have to be taken very seriously. So even though we see the fake news as a challenge, we still cannot ignore social media, and we're utilizing that also to transmit positive information that is based on science, research, and evidence-based. Collaborations and partnerships are extremely essential, and with academia, the universities is very important. Data analytics and appropriate communication are essential in the management and control of the COVID-19 pandemic. So we're looking forward to innovations that will help us enhance data analytics and appropriate communication. The COVID-19 pandemic has caused a leapfrog of the fourth IR and a new norm. Whether we like it or not, we are on WhatsApp. However, we still need to remember that no amount or quantity of AR or fourth IR can replace the human beings in the healthcare space. Because healthcare is a complex and a labor-intensive industry. If you remove the human beings with the most beautiful technology, it also remains a challenge. So there has to be an integration, there has to be an interface, there has to be collaboration of technology and skilled, knowledgeable human resources. Compassion, knowledge, and skill remain key in the delivery of healthcare services, and we depend on these innovations. So experience in the University of Life, that is work, community, and service delivery, is priceless. So your experience as a TUT in research and innovation is very key in helping us in how the development of health to combat COVID-19. And COVID-19 has taught us how fragile we are. We are extremely fragile. We need one another as the human family. And these are my references, thanks to Google. And please let us continue to vaccinate. I thank you.
Thank you so much. Just to bring to your attention, a slight change to the program item. We are now going to move to the next item of the stakes of deep tech startups in France and at the University of Paris, SARChi. I'd like to call Prof. Bernard Yanu, the Director of Valorization and Innovation from the Graduate School of Engineering at the University of Paris, SARChi. He is joining us online as we are in a hybrid seminar. Over to you, Professor Bernard Yanu. The platform is yours. Thank you so much.
Thank you very much. I must tell you, I'm very happy to be there in South Africa with you, even if I'm a lot of kilometers far away, close to Paris. Then hello to South African and hello to colleagues. I am a professor first in design engineering and design of complex systems. And I'm also the director of an industrial engineering research department at Centrale Supélec. Centrale Supélec is a French engineering school, which is a component of the newborn University Paris-Saclay. And I've been elected as a director of valorization and innovation and entrepreneurship in the new engineering graduate school of the whole Université Paris-Saclay. Then for making you a bit more concrete what the university is, this is, it is a very recent university created 6 years ago in 2015 from 4 engineering schools in France, 2 big universities and 4 research institutes. And it resulted in almost 50,000 students, more than 4,000 doctorates, and more than 10 and 11,000 researchers in the south of Paris. And all these researchers represents 15% of the whole French research, including public and private researchers. The whole, all researchers are working in 275 research laboratories. Then that's a big university, the first in size in France. And you can see here other pictures of this university. This is a multi-site campus made of 3 or 4 different sites located on a plateau 30 kilometers south of Paris. And all these buildings are very new buildings. Then a lot of money has been put in there under the presidence of President Sarkozy. He decided that we should have an international reputed and very big university. And consequently, we have a lot of disciplines, and we are organized in 18 graduate schools, spanning from, Biosphere, which is a school of environment, agriculture, and biology, school of chemistry, physics, and economics and management, and also of sociology, political science, mathematics, etc. And of course, we have the School of Engineering and System Sciences, which is, by the way, the most important one. In one slide, we are organized around 9 engineering disciplines, spanning from material science, chemical and biochemical, optical science, telecommunication, industrial and manufacturing engineering, fluid and solid dynamics, mechanics, electrical engineering, automation, and computational science and applied computational science. Engineering disciplines represent more than 70 laboratories, almost 3,000 researchers. We have 600 doctorates organized in 4 doctoral schools, and we have more than 7,000 students and 10 master programs. We definitely want to create value for industry, but also for society. And this is why we published in very good journal, of course, theoretical papers, but we want also to apply and to organize how we create value for different business sectors. Then the result of this newborn university is that we have been ranked for the first time last year in the Shanghai ranking. And for the second year, we have been ranked 13 for the whole university. And we are the first ranked university in the continent, European continent, continental Europe, just after the 2 English ones, Cambridge and Oxford. If you look at the different disciplines, we are ranked first in mathematics, 9th in physics, 12th in agriculture, and then we have different disciplines in engineering, which are classified in the 51st university. If we look at engineering disciplines, we are 29 in telecommunication, and 30 in biotechnology, 41 in mechanical engineering, and electrical and electronic, we are under the 70s. Then we had a concern in France for 2 years. We would like really to use the research we have, and we are quite good in research in Europe, but we would like to use the research potential to create new businesses around this new knowledge that researchers are supposed to create. And 2 years ago, the government decided to put a lot of money, like almost 3 billion euros, in a big plant over 5 years for increasing the number startup company coming from research, what we call deep tech startups. Deep tech means this is deep knowledge outcoming from research, and that let hope to create very strong startups on a given technology, which is not easily copyable. And today we are not champion. We only per year in France, we have 200 deep tech startups created, and our objective in 3 to 4 years is to reach the creation of 800 deep tech startups to be at the same level than Great Britain, for instance. And for that, the government and in cascade, our university are providing a lot of resources on that, like very professional accelerators for allowing doctorates and professional researchers to create their own startup with a lot of advices and for accompanying and for the ideas to the market. Like we say, we have incubators, we have meaning for additive manufacturing and any kind of transformation into proof of concepts. We have more and more we develop training for researchers to become not especially CEOs of startups, but maybe they can stay advisor or only CTOs if they don't dare to be CEOs. And a lot of public and private funding also is available as soon as the project has reached a level of maturity and value. Then we have a tool in France, which is BPI France. BPI means Private Bank of Innovation. And that's a unique bank where you can apply when you have a good innovation project. And if this project is assessed very good and very, very promising, we have a very quick review process with experts. And if this is the case, then if the label is given, then money is given and advice and meaning for startup to be hosted in incubators. Then this resource and starts to be very, very efficient. And we have a lot of resources. Then in our graduate school of engineering and system science, my concern and the one of my 73 colleagues who are directing the labs is to make our researchers, our colleagues and our doctorates sensitive to the question, is your research, can your research conduct to create some value, like filing a patent, or more to create a startup with the help of your colleagues, with the help of students and other professional people? Is there something in your research that can go and create value in the market? Then today we are not very good. We have only a few deep tech per year outcoming from our graduate school, and we decided to define a realistic objective, and maybe that's not realistic, but I announced this figure of 15 deep tech startups that we could create in a few years per year. If it amounts of maybe if each of the lab could create two good ideas per year, we could have 150 ideas. If all students can provide some ideas, we could have 2% of students providing ideas for the amount of 150 ideas too. Then with these 300 ideas, if we think that maybe 5% of these ideas can create valuable and sustainable startups, then we have created our 15 startups. Then we want really to to inform more and to convince and to collect and supervise more and more PhD doctorates work, to be able to train these doctorates as soon as possible in doctoral training on entrepreneurship. We also organize on the university entrepreneurial expeditions with doctorates, but also with master of students from ideas coming from the labs for training them on what is the construction of a startup. And we want also really to mix students who are not dedicated to all make doctorates, but master of students can be very willing to start a startup, whereas doctorates maybe are a bit shy to be entrepreneurs. And we have to mix and to compose good teams. Then we make people meeting with offer and demand and composing really teams for starting an entrepreneurial project. And we have also a very strong organization which is called the Accelerator and Technology Transfer Structure, SAT, Paris-Saclay, with 20 professionals, and they are accompanying the project of entrepreneurship. As soon as it is detected of a high quality, then we organize a detection in the labs. We provide the ID to the SAT, and the SAT then coach the project, incubate it, ask for funding, and help the project to mature and help the startup company. These things are working very well. Now we have just to increase the of people and startup created. Then I just want to finish with two examples of startup recently created. We have this 22 startup created in the last 4 years in engineering, in deep tech, that you can visit on the web link here. And as it was a seminar on the SARChi chair, I selected two examples based on assistive technology. The first one is started 4 years ago, Ublex, that proposed a gyropod transportation system, which is very smart because the center of gravity is very low and it allows to have a very good stability. Let me show you something, some demonstration. This kind of transportation means is very convenient for big logistics warehouses, for instance, where people have to walk for 5, 10, and even 15 kilometers per day. And the company is made of seven people now, and is very successful for industrial plants. The second example is an example called Chiron IT. Chiron IT, this is also 6 students of the university who have created a system for track camera the different sportive movements of someone and tracking the different articulation and members of the body for accounting the number of movements and advising for instance, the training of a sportman or sportwoman, or some image on that also. Okay, just for concluding, we really hope that fostering and boosting deep tech startup is one way for re-industrializing the French territory and to be still competing in innovation at a world scale. Thank you for your attention.
Thank you so much to Professor Bernard Yano. Our next speaker would also be joining us on the virtual platform. As we allow him time to connect with us and get ready, I just want to remind you of the bathrooms as you exit the auditorium. Towards your left, it is the male toilets. Towards the right, it is the female toilets. I'd like to encourage you also to continue observing the COVID-19 regulation. All right, just also to note for your attention, we are going to continue with the program. The next item that we are going to continue with is I'd like to call upon Professor Juani from Tshwane University of Technology, PUSATI, and UPEC to come and enlighten us really on the research and innovation activities within the SARChi chair. Professor Juani, over to you. Thank you so much.
Good morning. First of all protocol observed. Dr. Vachiwa Papu Zankaya, Professor Lawrence Van Staten, Vice Chancellor and Principal TUT, Orient Chevalier, His Excellency the Ambassador of France, Mr. Lawrence Matemba, Acting DDG, Policy, Research and Services, Dr. Gansan Pile, Deputy CEO of NRF, Dr. Fridi Gonkawa, Acting DDG, Hospital Service, Department of Health, Dr. Yves Guénon, Chairman of the French South African Chamber of Commerce, Professor Bernard Yanou, Director of Valorization and Innovation, Graduate School of Engineering, University Paris Saclay. Thank you, dear colleague, honorable assistants. Thank you very much for your making time to be in this event. I will just give an overview of the context of this event, not to talk only about the chair, but to give you an overview how we can move forward to establish a new collaboration that are effective on two objectives: human capital building, innovation, and making sustainable impact to economy and to society. Sorry. I'm supposed to use this, huh? Okay. Okay, the objective of this event is to discuss three aspects related to robotics, Internet of Things, and artificial intelligence in one context, which is assistive technology. I will get you through 4 points. I will take 5 to 6 minutes to get you through 4 points to get to main objective. What we know, the know-how at TUT, and how we can deliver on the research and innovation with collaboration with other institutions and university, but also with industry. So if it comes to context, research and innovation here in our context, but also towards this human-centric technology, develop technology, but taking human into consideration. It was the talk of Dr. Friedi Ngonkoa that human must be in center, not we develop technology without having this human in mind. So we are talking assistive technology. The objective is clear. We develop a set of technology to assist people with several levels of disability in their daily life. Okay, but it can be extended to any assistive technology in this general sense. And different technology that you develop are set of Lego pieces that you can use in other contexts, like for IR, smart agriculture, smart healthcare. You can name them. So what we develop in this context can be extended to others as well. So what we build in the assistive technology, what our objective is to build technology with human in the loop. You have to take the human in the loop and interact efficiently. We will have different intervention today and tomorrow that will cover different aspects. One of these aspects is language. We will having Dr. Olga Schwenk from Facebook in France will be talking on this aspect of African language. We will discuss different possibility, how you interact with user, what is the interaction, machine-human interaction, and how you can get information from the user. This is set of technology that you have to develop. It's based mainly on Internet of Things, but also on this digital world, this digital technology. We will talk what is the impact of the telco operator in bringing this digital economy into life. But you need communication, you need support of innovative technology on communication side that will be enable that. But on the top, you develop services. Services are based on artificial intelligence. Artificial intelligence must be efficient, must consider human in the loop. We must develop emotionally awareness for artificial intelligence. So that's what we are talking about. It covers different technology for assistance from the development of devices, like you have seen in one of our demonstration on physical devices, a robot, wheelchair, whatever, is physical devices that you develop to assist people. You need to have an information on your environment. This is software engineering part, and in the middle, you need to analyze those data. This is artificial intelligence. On the link, you need infrastructure. This is Internet of Things, which is in our mind, one of the slices of 5G. If we want to deploy at large scale such kinds of technology, you have to work with telco operator and innovator in this sector to see how we can build verticals within the new emerging technology of 5G. So what we are talking here is a set of innovative technology from robotics to artificial intelligence with the support of communication systems that are able to enable what is digital world will be, with the human in the center of this development of technology. So we are looking to develop this open-enabled lab with a collaboration with different stakeholders from universities from France and across the world, but also with industrial, here local from South Africa, like Telkom and Nokia, and also with industrial in France. So the context of our seminar is on four aspects. Mobility assistance, how you can design innovative mobility system to assist people that have disability. The second aspect, how are you going to bring awareness on the user and the environment to your decision system? This is Internet of Things that you have to deploy to get information, collect information in the secure way, efficient way to get them to central decision or distributed decision. You go to cognitive assistance in the sense of your need of the user, and then you need to develop an artificial intelligence that consider human central and not human as an external user. So this is what the share is about. For aspect, embedded system design for Internet of Things with the support of Telecom Center of Excellence, Nokia and Telcom, but also with the collaboration of a French company, which is Comsys. We look to assistive device development. This is what you have been saying on robotic design, on assistive system design, and that's what we have developed with the startup of augmented reality. We develop a set of efficient algorithm that looks to emotionally efficient algorithm that take into consideration the impact of your decision on the emotion state of the person. And last and not least, all of this is built with software infrastructure. This is done on software engineering side. So we look to human-centric artificial intelligence, lot of constraints, main of them, empathy. You need to make a decision like a human. You make it not like a machine in collaboration with the human. You make a decision in that sense. So you have to consider impact of emotion on the human. Transparency, trust. We will have people that will be talking from Atos, France. They will talking of this AI that bring trust. Your decision that you have to make must have a level of trust. Whatever is your algorithm that you deploy, you have to check that the trust is there. And we will have different people from academia and from industry that will be talking about trust and about transparency and about ethics. At the end, you have to consider that artificial intelligence must take into account ethics consideration. This is the need of tech support. We cannot do digital world without telco operator. So what we know, the know-how at TUT is that we are aware from the component, our object, to the core of the network of the telco operator, to the cloud and service delivery, how to do it. So we need to work together on the verticals and how we can think about this living lab, open living lab that is able to validate and generate real knowledge for economy. That's what I put here. Telco operator will be support of this innovative technology, this smart agriculture, smart campus, smart healthcare, whatever you name it. They are part you need to high speed, high availability telco network. I think I am almost done. This is just a reminder what digital world is. We are able to work on different levels, from software, embedded software in chipset, to cloud service delivery and artificial intelligence for this emerging digital world. Those are the different questions that we're asking our people. What are the challenges and trends in artificial intelligence in a general sense, but also in different kind of application? From medicine, we will having doctors that are from France that will be considering pathology and therapy impact on user, how you can look to the path of therapy for different patients. So we applying artificial intelligence. Professor Calderaro will be talking from UPEC University on that topic. We are working together on this artificial intelligence for medicine. We will having people working on science, on materials and chemistry. They will be looking to materials, how we can use artificial intelligence to generate a new innovative, design a new innovative materials. We will have Jean-Claude Crivello from UPEC, also from CNRS, that will be talking on that aspect. We will have people that will address cognitive robotics, assistive robotics, how you design effective system for assistance. We will have people from United States and from Germany and from France talking together on how you are bringing assistance by analyzing human activity and analyzing the need of the user. We will look to challenges in Internet of Things, how you are managing critical communication, how you are managing design of effective Internet of Things for IR, for instance. And then, last and not least, what was Bernard Yanou talking about is what is the support for student, for researcher to go from research to innovation. So thank you very much.
Thank you so much, Professor Joanny, on enlightening us on the activities within the SARChi chair. At this point, we are going to break. We are going to take a 20 minutes break. Also, just to note that there are refreshments at the back. So please, also the technology demonstrations by the exhibitors, I'd like to encourage you to please visit the exhibition stands. We are going to take a break now. On my time, it is 12:20, so we should resume at 12:40. Thank you so much. This is a hybrid seminar, so I'd like us to please observe time so that we can also respect those that are joining us online. Please enjoy the break and the refreshments, and do remember to visit the exhibition stands. Thank you so much. Ladies and gentlemen, I'd like to encourage you to please conclude your refreshments and make your way to your seats. We are about to begin. Please conclude your refreshments, your interactions. We are about to begin. We are continuing with the program. I'd like you to please make your way to your seats so that we can proceed with the program. Thank you. Start. Ladies and gentlemen, we are proceeding with the program. We are continuing with the keynote addresses to the SARChi Chair in Enabled Environment and Assistive Living, Research and Innovation Seminar. This is a hybrid seminar. I'd like to welcome back those who are joining us online. We are continuing with the program. The next item that we are going to continue with is strategy on innovation and academia industry collaboration. Please help me to welcome Dr. Nick Bradshaw, the CEO of AI Media Africa. He is joining us online on the online platform. Dr. Nick Bradshaw, welcome and thank you so much.
Hi, everybody. Nice to be joining you from the west coast of South Africa. I'm up in sunny Langebaan right now. So just going to give you a quick insight as to who we are. Trade Analysis Publishing and Events Company at Cape Town. And we essentially started mapping the South African AI ecosystem towards the end of 2017, early 2018. And we basically realized there wasn't really much dialogue going on between business, academia, industry, investors, startups. And so we created an event called AI Expo Africa, which happens every September. We publish Africa's only 4IR-focused magazine. It's a digital magazine. And we provide industry insights as to what's going on across the community in South Africa and wider Africa. Our outlook is global, and we very much act local as well. So we set out to build the largest B2B community in the region. And really what we're trying to do is catalyze relationships and partnerships and interactions between industry, academia, government, embassies, society, business, and innovators. Our 6 main activities we're engaged in: connecting people, sharing knowledge, showcasing the best of South African and African innovation. We signpost people to education opportunities. We provide support to government and business and embassies in terms of what's going on in the landscape. And the final thing is we're about creating opportunity, whether it's employment, investment, or international or local trade. I think for us to look at the link of innovation with wider society. We have to think of it as a continuum. This is something we created about 3 years ago. We call it the 4IR economic pipeline. And really what we need to try and look at to optimize inclusion for everyone in the fourth industrial revolution is we have to look at everybody from the global corporate end of the spectrum right down to people who have lived and been brought up in previously disadvantaged communities, and then everybody in between. And we really do see these interfaces as being key. And this is one of the key observations we made in 2018, is that many of the interfaces between some of these communities and entities are actually, they're not very well integrated, and they can certainly break down some of the silos and integrate for better effect. So we call this pipeline the 4IR economic pipeline. And if we can optimize this pipeline, we can start to really generate growth in the region around this particular sector, which also involves academia, innovation, and industry. Even though the fourth industrial revolution, if we want to call it that, is fairly new, it's a new concept, perhaps, maybe a marketing tagline in the eyes of many people. But there is actually a lot going on when we start to look at that spectrum and how we can involve young people and inspire them into the learning opportunities and a learning pathway which could then take them into new environments, getting involved in further education, research, and entrepreneurism. And many of the, one of the interesting facets about the particular technologies, their availability and access, assuming that you do have connectivity, the barrier to entry is almost zero in terms of cost. So assuming you've got connectivity and you've got access, many of the resources and programs that you can access are free. And there's various initiatives in South Africa, there's various initiatives across across wider Africa. One such interesting one is Data Science Nigeria, which is setting out to train 1 million people in machine learning and data science over the next 10 years. And that's a not-for-profit education platform, working with people online and offline as well. So there's a lot we can learn about some of the education pathways that can lead people into research, innovation, and then into entrepreneurism. The spectrum, we spend quite a bit of time talking to embassies and trade missions, as one of the routes into this particular event was through the French embassy and some of the relationships we have with them. But we're inward and outward focused. So not only do we want to grow the country, but we also want to help organizations in the country. That's another important aspect of innovation, entrepreneurism, and value creation, that it has to find a way out of the country into new markets. If we look at things like readiness, I direct people to the Oxford Insights website on the global national readiness of countries for embracing artificial intelligence. I think it's fair to say that Africa has been traditionally behind the curve, I guess for fairly obvious reasons in most respects, but we see some very positive signs in countries like South Africa, Egypt, Tunisia, Ghana, Nigeria, Kenya, Rwanda, really now starting to put in place the foundations for exploring and extolling the virtues of some of these new technologies. And then if you look at responsible deployment of AI, we can see that countries like South Africa are leading the way in the continent, which is a very positive sign. And I think some of the dialogue around the Presidential 4IR Commission is really given a thorough look at all aspects of how the nation can exploit this new revolution of technologies that we're all experiencing at the moment. If we look at investment, again, innovation and the liberation of IP, generally funded, it needs to be funded, you need investment, you need cash. And if we look at things on the continental level, particularly in the tech sector, South Africa is no longer the #1 destination for tech investment. It's now got 3 main rivals, that being Egypt, Kenya, and Nigeria. And each of those regions is influenced in very different ways. We don't have time to go into that today, but I direct people to the research by Max Imbayan and Max Revelia on this a particular field. They are experts in looking at the tech investment landscape in the Africa region. If we look at the interface between entrepreneurism and universities in the education system, and we look at the liberation of IP into early stage entrepreneurism, the amount of funding that's available for that is highly constrained, if tending to zero. But there are some initiatives that I guide you to look at this. We've got the Cirrus AI initiative that's being run at Wits University, which is building a fully funded incubation and accelerator linked ultimately to a supercomputing facility in the future. But the idea is that it'll be a Pan-African resource where startups and entrepreneurs can look at spinning out technology from universities, not just Wits University, but looking at academic and research institutes across the continent. So again, if anyone wants to follow up on that, happy to do introductions to the team if they're not already engaged in the event today. The other interesting related initiative is the AI Africa Consortium. The Cirrus group are involved in that, as are we. And again, it's really building a coalition around unlocking the value of IP, R&D assets which exist in the academic environment. Again, this is not a place where private capital likes to play. It's often seen as high risk, but there is an increased interest in this particular interface. So again, direct people to that those two initiatives if you're interested. If we then move on to, sorry, I just got to change my screen here. If we then move on to some of our own initiatives that we're working on, we've actually created a deal-making room where we're connecting investors that are local here in South Africa to early-stage entrepreneurs that want seed capital or growth capital, and you can find that on our website. If we then look at the wider ecosystem, it's important to note that about 3 years ago, there was no information whatsoever from the analysts on the AI ecosystem in Africa/South Africa. And so over the last 3 years, we've actually looked at almost 2,000 companies, and we started to map out where these companies are founded, where they're located, the size of the company, the kind of activity they're involved in. And it's very interesting to see that South Africa has the highest concentration of these companies on the continent. More interestingly, it's nice to see a small country like Tunisia coming up second in this particular analysis we've done. And this analysis is dynamic, it's changing all the time, but the top 6 countries, South Africa, Tunisia, Nigeria, Kenya, Egypt, and Ghana, account for almost 80% of all the activity in this particular sector. If we then break that down by South Africa and we start to look at where these companies are based from a South African context, we see that most of them in the Johannesburg, Pretoria region. I guess many people probably think they're all based in Cape Town. So it's interesting to see that the Gauteng and Tshwane regions perhaps could be labeled as the new AI tech capital of Africa. And that's something we're actually working with Gauteng and Tshwane Economic Development Agency to promote as well. But a very positive sign for our region. These technologies are cross-cutting, as we all know. So they are, if we look at sectors, pretty much every sector is being impacted by these technologies, including obviously health. We're talking about, I guess, assistive living, but there's some very interesting things going on in that particular space. And the other analysis that we provided that came from this research was that most of them are small companies and most of them are privately held. One very, very positive sign from our research was that there's been a doubling of the number of these companies every 5 years. And we're going to break this analysis down in our next iteration to look at it over a shorter time scale. But this growth curve is very positive for the development in our particular region. If we then start to look at skills, most of the skills and jobs in demand in artificial intelligence, data science, and cloud computing are, again, in the Gauteng region. Again, another positive attribute for the sector. But obviously there are some challenges with that as well. And if we break down what our community are telling us are of most interest to them, clearly data analytics is a underpinning interest, but our community is talking about all sorts of different technology. The number one, or the top three technologies of interest is augmented reality, virtual reality, and mixed reality. That was before all the announcements about the metaverse. These are analysis from earlier in the year. So yeah, we've got, it's not just about AI. There is a whole mixture of converging technologies which are coming to bear at the moment, and it's quite a dynamic space. As I mentioned, the challenge around skills is that they're quite short-lived, and I think that's one of the challenges for governments, I think, to adapt teaching and learning curriculum. But we'll probably find that most people are acquiring skills independent of those learning environments. It's learning online, learning through specific programs, not-for-profits, etc. So again, the speed of evolution in this particular sector is quite fast. The other thing that we set out to do was map the African AI community. Again, if people are wanting introductions to some of these particular groups, I'm very happy to facilitate that. But we look at academia, we're looking at accelerators, incubators, not-for-profits, NGOs, and also we're working with the ITU about localization of some of their AI for Good Africa programs. That's a relationship we started with them in 2019. And a good example of some best practice about at the national level, the Kenyan government were the first government in Africa to in an AI strategy. It was published in 2019, and direct anyone links who's interested in looking at how they're approaching things at the national level and using these technologies to look at things like food security, housing, healthcare, manufacturing, cybersecurity, land titling, and also eliminating corruption. Maybe there's a lot we can learn from them as a nation and how they've gone about that. Just to wrap up, if anyone's interested in getting involved with what we're doing in this community and this kind of conversation, we run an annual gathering. It's called AI Expo Africa. It happens in South Africa in September. The first 2 years were face-to-face events, and the last two have been online events. But essentially, what we're trying to do is bring that economic pipeline together: academia, innovators, investors, corporates, governments, startups, learners, and bring everybody together under one roof for a couple of days to have a conversation about this particular topic. It's very applied. It's an easy conversation to get involved in. You don't necessarily need to be a technical genius to join the community, and we obviously reduce the barriers to entry, particularly for young people, making it a zero cost engagement for them. We're going to be moving our event to Joburg next year, and it's going to be a face-to-face event, which we're all really getting excited about. But the key thing is that we're also running a leadership event at the CSR in May next year, and we're going to be having various panels where we're starting to connect up some of the very interesting dots around innovation, trade, investment, entrepreneurism, government, and business. So again, something to look forward to next year, but the main event will be in September. The final resource I can leave you with, if you want to track what's going on with innovation and some of the information that we publish around this topic, please sign up for Synapse magazine. It's a free quarterly digital magazine, and you're most welcome to read that at your leisure and look at some of the news that we're putting out about some of the great innovations which are coming out in our region. So thanks very much.
Thank you so much to Dr. Nick Bradshaw on enlightening us on such a pertinent subject on collaboration, the strategy on innovation. Next up, to address the SARChi chair on the subject of mining resources for machine translation of many African languages. Ladies and gentlemen, please help me welcome Dr. Holger Schrenk, research scientist of Facebook AI Research Laboratory. He's joining us online. Let us welcome him to the platform. Over to you, Dr. Holger Schrenk. Thank you.
Good morning, everybody. Just a quick check. Hello? Okay, thank you. Good. Oh, okay, first of all, I would like to thank the organizers giving me the opportunity to present this work, and also my colleague Eric Monacelli, who made this possible. So I would like to share with you some of our research with the goal to put the natural language processing technology to more languages, in particular African. So if you look at the languages in the world, the language is very important to maintain them. So we have about 7,000 living languages, out of which 40% are considered to be endangered. What does it mean? They're spoken by less than 1,000 people. 23 languages account for half of the population, and currently machine translation only covers about 100 languages. And if you look at Africa, it's roughly 1.3 billion people, and we have between 1,250 and 2,100 languages. Why this range? Because it's not actually so easy to number them. And if you look at current MT technology, only 10 are covered by machine. So it's clear here that somehow current machine translation technology doesn't cover very well all the people in Africa. And also we know that access to information or other national language processing application requires now the translation from and into English. So our research goal is now to significantly extend the coverage of African languages. To tell you how this is working, let me give a little bit technical background how we attack machine translation. So today, basically all artificial intelligence models that don't explain these rules what you should do, but we just give data, typical data, and they learn from data. And usually, the more data they have, the better they perform. So the two types of data, one we call supervised, so we have a sentence, and translations, what we call parallel data or bytetext. So most of these resources come, for instance, in Europe with the European Parliament, which translates the proceedings. The text of United Nations appear in many, many different, several languages. And of course, normally do not ask humans to translate some text with a purpose to build machine translation system, because it's quite expensive. So this is what we call supervised training, where we have desired output, and we can also process raw text. We just have text in many different languages, so no translations. And then the system learns something like a generic representation of the data, which then can be adapted to several tasks. So the question, how do we want to represent words or text in a computer? This could be, let's say we have a list of known words, only 3 words right now, between code with this type of vector, and we want to represent this graphically. It would be on a cube where each word is in the corner. So the apple, the car, and the automobile. This is not so bad, but actually the big disadvantage is that if you want somehow to get the notion which words are similar, and you look at the distance in this cube, actually all words have the same distance, the diagonal. So between an apple and a car, it's nothing more similar between a car and an automobile. This is a big problem, because what is artificial intelligence is to know what to do on something that you haven't seen before. So if it has a sentence, this is a nice car, and now you replace car by automobile or apple. If you have a representation like this, you have a lot of trouble to know which one is better. The main idea in artificial intelligence about 20 years ago is, instead of putting the words on the corner, let us allow any position in this three-dimensional space. And obviously, we want to learn that apple, bananas, and grapefruits are close, because they are fruits, and cars, automobiles, and vans, another space. And if we happen to learn this, we actually can make the generalization, and we have the sentence, this is a nice car, and this is a nice automobile, that they have the same meaning. They're very close, and much closer than this is a nice apple. Okay, this is nice, but words alone are not pretty useful. So can we go to the same thing for sentences. That's actually what we've done. So we want to learn representation of a whole sentence and represent it in this high-dimensional space. For instance, we have a sentence, the dog is brown, which is somewhere here, and then I love eating and I enjoy food a lot. So these two sentences, the word overlap is very low, but it has more or less the same meaning. So we want them to be represented close in the space. Then we push it even farther. Instead of having sentences which have the same meaning, the same language, we want to have sentences which have the same meaning but written in different languages. Ich esse gern, or here. We have German, French, any language. Let me go back there. So it's a nice thing if you can represent a sentence the same thing that is coming the meaning. So a representation of the meaning. And we want to use this to find additional data to train on machine translation systems. So the idea is pretty simple. So I looked, in South Africa, you have at least 3 journals. Newspapers which publish in different language. I think it's Miami. Yeah, I have no idea what is written here, if it's good or bad. And now the idea is, can we automatically pair sentences among collections or raw text in several languages? So imagine that these 2 journals report
Dr. Papuzamzaka, in their absence, Prof. Lawrence van Staden and His Excellency Aurelien Le Chevalier, Dr. Freddy Kongwana, and Prof. Gianni. And all other esteemed colleagues. It's a pleasure to be here today, and thank you for the opportunity to just share a few thoughts on some of the work that we're doing on the telecom side in this context. And yeah. So I wanted to start off just giving you a quick overview of my team. My name is Stefan. I head up, whoops. There we go. So we are a team of about 55 data scientists, data specialists in the Telkom Group Center. And our focus is to really unlock value for the Telkom Group and for external companies that we partner with. In particular, we've structured our team across these 4 areas, kind of focusing on data management, data engineering, insights, and artificial intelligence. And so probably 80% of our work we spend internally in the group, delivering services to our group companies, which you'll see listed at the bottom. So our Telkom consumer business, BCX, who delivers ICT enterprise services, OpenServe, who is our broadband infrastructure provider, Gyro, who is our towers and mast and property company, and YEP, who looks after our small and medium enterprise market. In terms of those 4 focus areas, I wanted to just touch briefly on each different element and what our vision is in relation to this. So as a strategic partner to the business, we aim to help transform Telkom and the group in terms of how we operate. From a data management perspective, this is really about embedding data governance and good data management principles in each of the businesses to drive the data maturity and the data literacy within the group. From a data engineering perspective, my team has responsibility for, in particular, the cloud platforms and the data science environments that we work on. And so they manage the platform and the pipeline for data science solutions within the group. From an insights and analytics perspective, this is then focused on more structured data problems, forecasting, and our team here then really works on machine learning or advanced analytics models within that structured data context. And then we've got a specific AI team that is focused on leveraging AI technologies for unstructured data problems. Here we've spent most of our time looking at speech services, as well as so natural language processing problems, as well as some computer vision tasks. So I thought rather than giving a kind of a deep or a broad overview of some of the different elements of work that we do and how that might be relevant today, I wanted to focus on really 2 areas. One is the work in speech services that we've embarked on over the past few years. And the second is a focus more on the IoT side, looking at the smart home context. So our team has been really focused on developing machine learning models that help us transform audio and video into text. And so, as we heard Dr. Schenk, unfortunately we couldn't hear much of what he was saying, but really in that same context, we've been developing speech models and language models for South African English and for other African languages to help deliver broader application in the education, healthcare context. And we believe this is one of the key future interfaces for businesses, for industry in Africa. And so really critical for us as South Africa and Africa to be developing the skills that can deliver services in this regard. this is maybe just a bit of background on our speech services journey or our roadmap. So the initial work that we embarked on was really to create what we talk about as these Telkom speech APIs for South African English and for some of our other South African languages. This really is a core asset that we then hope to leverage in a number of other areas. The first is a platform that we've recently, was in almost pre-launch phase, and later in December, we'll be launching in the first release of the actual platform called Izwe.ai. Here we've partnered with a small startup called Enabler to bring together the machine transcription and machine translation components together with human-in-the-loop data labelers that allow us then to do transcription and translation at higher levels of accuracy. Qonda is then a focus using the same underlying assets into contact center space. So bringing typically where there's a high dependence on international data assets to drive call center transcription. We are now leveraging our internal tools to be able to automatically transcribe call center data and then to deploy deep speech analytics or text analytics on top of that to deliver value in that contact center environment. And then a number of other areas where we believe these assets can then be deployed. And this is an important commercial avenue for us, but we also believe it's a key area that we need to partner with research institutions to develop this capability. And a lot of the work that we are doing is off the back of work done locally in South Africa, and even using some of the technologies that Dr. Schenk talked about in his previous session. So this is just a quick view of what Izwe.ai is. So multilingual technology platform that transform audio and video data into text in your local language. And the idea is here just to create a platform that allows transcription and translation that allows these assets to be used and to build up over time to deliver and meet a number of different use cases in the South African and African context. These are some of the initial services that we are starting to take to market. The first release will only release our English machine transcription. Then we have Afrikaans and isiZulu kind of going live next. The translation element, because we partner with what we talk about as the human-in-the-loop provider Enabler, we can deliver the translation services seamlessly from the start. And so we do that in a number of languages already. We then have developed a number of text classification and entity extraction components that can then add value on top of the basic transcription and translation services. But those are typically more bespoke. Use cases for these types of services are quite broad, but some examples might be interview transcriptions, contact center solutions, legal and government recordings, and then a number of different customized solutions. So quite broad application, not novel, apart from the sense that we are hoping to bring that local language context and expand that so that these assets also reside in the African content. Okay, so that's a quick view of the speech services work that we're doing. And then maybe to move on to the more IoT application and smart homes, and really picking topics that are kind of relevant for this audience, but also kind of close to our hearts in the Telkom group. And so as a data scientist, thinking about how we use IoT data to enhance individuals' lives is really critical. And so we talk about that as towards connected intelligence. If we look at smart home adoption, this is a report by Statista in 2021 that shows that smart home adoption is really starting to progress up this adoption curve. We can see that France kind of sitting still at the end of that early adopter phase before reaching early majority. And interestingly, I mean, I've taken a look at some of the TGI market research to try and plot South Africa in this scale. And TGI kind of puts South Africa at 12%, and that surprised me a little bit. I think if we look at the kind of broader South African population context and where we have 16 or 17 million households, I think this is inaccurate. I think we're then really much lower down that scale. I think if we look at the connected homes where broadband services are already available, then this is probably a more realistic estimate. In particular, they kind of mention that in South Africa, smart home adoption is really being driven thus far by smart security devices. So kind of linking your cameras or your alarm systems to the internet so that you can manage that remotely. So what are some of the barriers to smart home adoption that we see? And this is well known. Connectivity is obviously a key one, and this is an area that Telkom, as a telecommunication service provider, obviously also plays a big part in addressing. So these IoT applications or smart home adoption really requires increased access to broadband and kind of at lower cost. But secondly, probably also as important is around this idea around value. I think the smart home market in South Africa is quite disjointed. You can buy a smart light bulb or a smart, maybe a smart TV, but they don't come together. And so there's often not much value that's realized across that smart home context in South Africa. And so the question is, how do we improve that? How do we derive more value for individuals or consumers from smart energy or smart security solutions? Then cybersecurity and privacy. I think this is an area that's very relevant today around data privacy and the opportunity for attack through even IoT devices, but not something that I think is top of mind for current smart home consumers. I think for me as a consumer to think that my smart security system might be breached is probably, I'm not technologically advanced enough to kind of be too concerned about that. But I think as we head into this, as we head up that adoption curve, this will become increasingly relevant. And then on the other side of the scale, we deal with tech complexity and interoperability and stability through to installation and troubleshooting concerns. So really, if I think about interoperability, and this is something that I had a discussion with Prosper around the Hello Wi-Fi and some of the smart campus solutions that Tshwane University of Technology is also developing, getting to a point where there are common standards for our IoT devices and how we manage that is really important, and there is movement in the right direction, but still very problematic. And so as a consumer, I might have devices that are not interoperable and that can't be connected to the kind of a same control device. In South Africa, obviously, enabling our devices to be able to operate offline is also critical. So not being able to manage your smart or to use your smart devices if there's no power or no internet, or in particular no internet, might be problematic. So is tech working for us, or are we working for tech? And I think the question here is really around individuals, or in our context, customers, and how we help them to derive value from these solutions. With IoT as really one of the key exponential technologies in the world at the moment, it really brings this world of technology to our fingertips, brings it into our homes. And so that's exciting. and a real opportunity for businesses and researchers to allow societies to make progress. But often we are overwhelmed by the daily demands that, and technology often exacerbates that. If I look at the kind of new normal in this post-pandemic or kind of pandemic time, then we are so busy on our phones. There are so many messages, so much information that is coming at us that we are doing our customers and individuals a disservice, and the stress and the pressure that we're putting on them to be able to deal with all of this information. Now, if you think about that in the context of a smart home, if you want someone to make use of your technology, how do you help drive that adoption in a way that is simple for a user to understand, so that they can think about, so that it's easy for them to engage and that they're not overwhelmed with the technical complexity of interoperability or kind of control interfaces? How do we help customers also adopt and move along that technology curve? And then lastly, if we think about this information overload, how do we not continue and exacerbate this overwhelm, this pressure that that individuals are experiencing, but rather, if you think about it like a flower, if you have a flower or a plant that you want to see grow and develop, you water it measuringly. You maybe have a watering can and you daily give some doses or just some water that allows it to grow. You don't, as this picture illustrates, take the hose pipe and just blast the poor individual or the flower or the plant with that extra information. So how we manage information and the release of technology into that environment is really critical. So that brings me to this idea of connected intelligence, and this is not a new concept, but really I believe one of the key ways that we can support individuals and consumers or customers to kind of adopt also these technologies in our homes. So from a connected intelligence perspective, there's obviously benefits for customers, benefits for business. At the bottom, it starts around this integration of data across all of the devices. And then through real-time analytics to kind of move from the descriptive into the predictive and then into the prescriptive technologies. And it's really at that prescriptive end where we are able to move to actionable insights or recommendations that allows us to guide users through that experience. So if you imagine someone kind of being rewarded or kind of noted that they've made good progress by adopting certain steps or going through certain steps in setting up their smart home security system, or how they engage with some of the other smart devices in their home. And so being rewarded because they are energy efficient in terms of the smart energy devices, and really just almost in a gamified way, helping customers and individuals through that process. So anticipating their needs, integrating insights, and then delivering actionable recommendations that then unlocks value for individuals, but also for business. And so to bring that back to our speech services, for example, so one of the future areas that we're focusing on is really as voice as an interface for the future. Now, this is reality. I probably don't want to say Google now because my phone will light up and start speaking back. But in the African context, in our local languages, being able to deliver access to these services through speech services is really one of the key areas that we want to be focusing on in future. And so I think in the smart home context or in this IoT context, also an area where these two broader focus areas can dovetail and deliver extra value. Thank you very much.
Thank you so much, Mr. Stefan, for enlightening us on the SARChi chair on the application of AI and IoT in telecommunications. In this segment, I'm going to welcome back Dr. Schwenk to please conclude on his address on the subject of mining resources for machine translation of many African languages. Over to you, Dr. Schwenk. Thank you so much.
Hello. Can you hear me again?
Yes, are you?
Yes, okay. It comes and goes, so hopefully I can finish. So I'm not bringing back the slides. I just want to conclude, though. So we're very interested to bring machine translation technology and NLP more general to more African languages. And for this, we are looking for collaborations with local universities, because we just simply need text in all these languages. And I think the local universities and other agencies are much more better placed to know where to find this. And please reach out to me if you're interested in a collaboration. And obviously we will share back or make freely available all the resources we develop and also the machine translation systems we're developing. So thank you again for your attention, all my excuses for these technical issues.
Thank you so much, Dr. Schwenk, for concluding your address. In this segment of the program, we are going to have an address on the hyperconnectivity for augmented worlds. Ladies and gentlemen, please help me welcome Mr. Tim Nicholas, Customer CTO, Customer Experience Strategy and Technology from Nokia, South Africa. Let us welcome him to the stage. Thank you so much.
So, good afternoon, ladies and gentlemen. Let me get that there. Let's just get the slides up. Okay, so as mentioned, I'm going to be talking a little bit about what I call hyperconnectivity for the augmented world. And I'm going to talk a little bit about where we are so I come from a networking company, a company that builds telecoms networks. And we're going to talk a little bit about where we are with those, what their limitations are, and where we're going to be going in the longer term future. And since we're talking to a university audience, I'm going to talk a little bit about what we in the telecoms industry, Nokia and other partners and other players in the industry are doing in the fundamental research environment today. So not necessarily the things that are happening now. We will talk to some of the things that are coming in now, but we're going to talk a little bit about what are we researching for the longer term. So for the end of this decade, what are the things that we're working on? And I think you'll see how they dovetail with the topics that are being talked about here around augmented worlds. And you'll see the limitations of telecoms networks today and where we hope they will go to in the context of this conference. So I'll also draw your attention to the slogan that we have now as Nokia. It's a relatively recent one. I can't remember what we had before, but we've now, our CEOs come out with the slogan that says, creating technology to make the world work together. And previously, our slogan was about connectivity, about networks, about things, about speed, bandwidth, those kind of things. But it's really important that from an industry point of view, we realize that actually we're not building networks for building networks' sake. We're building networks to get the world working together. So enabling people to do the things that they need to do. It's not just about machines. It's just not just about connectivity. It really is also about bringing people together. A couple of other speakers have spoken about the human and people being the center of the world. And historically, the telecoms networks haven't done that. And it's absolutely not been the case. And I think you'll see where we're going to in the future that actually we are going more and more in that direction. So, next, blank, next. Right. So I'm going to talk a little bit about where we are in the telecoms environment. So you have a bit of a sense of what's underneath and what you guys have the capacity or the underlying technologies that you have access to enhance what you're doing, and also where we're going to, and you'll see what you can take advantage of. So I'm going to talk about fixed line networks, and I'm going to talk about wireless networks. So a lot is spoken about 5G. I'm going to talk a little bit about that. But 5G, we say the world is going 5G, but 5G is going fiber. So in order for these kind of wireless technologies to work, they typically have very short distances. So they have a very high dependency actually on the underlying wireline technologies, which is fiber. Does this guy have a pointer at all? Doesn't really. Pointer? No. So you'll see over there on the left, somewhere towards the left-hand side, you'll see GPON technology. That's where we are in the fiber world today. And that basically gives customers roughly 1 gigabit per second. Well, nobody's deploying that yet in South Africa, but that's the capability that we have in the network. And that's the capability that we see is possible to be used. We are, in the next block, you'll see XGPON1, XGS-PON, NGPON2. Those are all 10 gig technologies. And those technologies are now going into residential environments. So we have a customer, so the predominant technology that we're seeing now in the 10 gig environment is called XGS-PON. We're seeing now in the residential space, 10 gig technologies going into the homes. And that is changing completely what is possible in terms of the communication between homes and cloud. So we're seeing a lot of artificial intelligence, cloud-based platforms, those kind of things. But you've got to get connectivity for those things to be able to add value. And we're seeing now that connectivity happening very, very significantly. So we have customers which have 8 gig services into a home. And if you think about an 8 gig service into a home, what you can do from a cloud and a home point of view, from a sensor, from a tracking of individuals, where are they, what are they doing, those kind of things. And we're going even further than that. So we've demonstrated 100 gig interfaces into a residential environment. So we're not talking about transport networks. We're talking about residential subscribers here. We've demonstrated with Vodafone in Germany, actually putting 100 gigabits per second on the fiber that goes into your house. So that's nowhere near commercial. That's somewhere near the end of this decade that it will be commercialized. But as you think about what you can do in terms of connectivity between your augmented mobility activities and the cloud, you can start thinking about actually you're going to have a huge amount of connectivity, a huge amount of bandwidth, and it's going to be normal. That's not something that's going to be super, super expensive for the unusual environment. We will see 10 gig coming into the environment very soon, and it will be of course more expensive than what we have today, but it will be at an affordable kind of price point. So that's what's happening in the fixed line environment. And you need those technologies in order for the 5G and the future technologies to come into fruition. So what do we have in the wireless world? So everybody's familiar with 2G, 3G, 4G, where we are mostly today. 4G introduced obviously higher data rates, machine type communication. So we're seeing a lot of the IoT activities that were spoken about before, but still relatively limited. 5G introduced a completely different scale of IoT and industrial activities, which I'm going to just remind us about. So I'm not sure if many of you have seen that, but this is the intent of 5G that was decided many years ago. This is probably 4 or 5 years old now. What was the intention of 5G? And you will see that it had 3 primary objectives: extreme broadband, massive machine communication, which is all the IoT activities, and critical machine communication. So really the industrial, the 4IR kind of stuff. But what you'll see in there is nothing about people. So it's about machines. So yes, there was an intent around people, but coming back to the comment about we need to get people at the center of our engagement and our activity, you will see that even in the 5G world, people are not anywhere near the center of that activity. The whole telecommunications environment is driven at the moment around industrial applications, machine activities, with, of course, a change in architecture. So we're having compute platforms coming to the edge, we're getting machine learning coming out to the edge, we're getting analytics platforms coming to the edge, but they are primarily focused around industrial activities. So that's where we are on 5G. So currently, the people that are deployed 5G at the moment are, you'll see there, focus on some early 5G adopters. So mostly what's happened in the world so far is people are deploying that very first use case. We will start to see in the next couple of years the second 2 use cases coming in. Those are just being deployed now, so you don't see those anywhere in the world yet. Those 2 really there. They will come, and they will create a platform for you guys to be able to build a much better connectivity into the environment. We will see in the massive machine communication, we're doing a lot of work to improve localization. So today, if you have a sensor on your body, or if you're trying to track somebody that's moving or fallen down, you can't actually see that because the resolution of the networks is not very high. You need to have external applications, external equipment to actually track location. So we will see in the next 2 or 3 years the network being able to track location to 1 or 2 centimeters. And if you think about that from sensor tracking, looking at where people are in a home or in an environment, in an industrial environment, safety environment, we will see significant improvement in there. But what comes after that? It is still machines. So what comes after that, and what the industry as a whole is looking at now, is really connecting worlds. And you'll see the difference in the picture. 5G, even if it's very high bandwidth, even if it's got lots of nice, cool stuff in it, it is fundamentally an industrial technology. So now we are starting nowadays to research what comes after 5G, because 5G, the fundamental research for 5G has already finished. Obviously, there's a long way to go. There's 10 years of building the technology, but the research for all that has already done. So we're now looking at what do we do next in the telecoms environment, and we're really looking at how do we connect the technical world, the physical world, with the biological world. And that's really what we are looking at now. So to give you some kind of a quick snapshot of that, just how am I for time? So I'm going to start at the bottom here. And the conversations we've heard around speech and communication by language is an indicator of the first problem that we see, is the human-machine interface today is completely unhuman friendly. It's primarily about typing and some speech, but for many people that speech isn't in the right language, and so there's a lot of activity, as was previously spoken around trying to help people engage through speech. But that's still not enough. We believe that the network needs to contribute to that more than having all these external applications. So the research that we and others are doing is to try and find out how can we, at a network level, improve the engagement and the human-machine interface, and to become much more gesture-oriented, movement-oriented, location-oriented, rather than, so speech, of course, will be important, but much more away from typing, engaging through an iPad or a PC or whatever. But that means that the network itself needs to develop the capability to receive input from people as opposed to a device. So we really see that we will move away from, obviously these kind of devices will be there, but over the next 10 years, we'll start to see that the network itself becomes a sensor rather than the device, and it becomes able to receive input from the individual. So that's a very, very important one. But obviously for the network to be able to do that, the network has to be able to understand what is actually happening. What is this change of environment that it's experiencing? And it will only understand that through machine learning and artificial intelligence. It can't know that by itself. That means the requirement for artificial intelligence, the requirement for machine learning is going to explode an order of magnitude to where we are today, because it needs to be able to actually feel at a network level what's happening. And so you'll see on the top left-hand side there, you'll see the notion of ubiquitous compute. So we are nowhere near yet the computing environment that we need for this type of world. We basically have, in the 5G world, we're moving this compute capability much further to the edge, but for industrial purposes. We need to now get that compute capability into the home or into the environment where people are, so that artificial intelligence can actually detect and understand what's happening in that specific location. So we're going to see a significant explosion in compute capabilities. We believe that the network itself will become a sensor. So today we use sensors to identify where people are, what are people doing. We believe and we expect that the network itself, through the radio technology, will actually become a sensor. So we're moving to terahertz. We are looking to move to terahertz type of spectrum, which is very short range, but has the possibility to actually be used to detect changes in the electromagnetic environment. And from that, we will be able to see what's actually happening with people. Have they fallen down? Are they moving? Are they in an area? Are they out of an area? And the network itself will, well, that's the research that is being undertaken, is can we get to the situation where the network becomes actually a sensor? So that's really what we're trying to do. We're really trying to get to the environment of combining physical, digital, and biological worlds. We are very far from that in the telecoms environment today, but we do believe that that's something that we will get to. So I think my time is almost up. So I'm going to just, this is kind of a snapshot of the key technology areas that we are working on in order to get to the next generation by the end of this decade. And I'll just take two. So the first one is spectrum technologies. Spectrum technologies, as I mentioned, we are changing the spectrum that's going to be used significantly. It'll give us much higher bandwidth and but shorter distances. That means we need to get the compute power, we need to get the backbone connectivity much higher into the network. But we do believe that it will enable us to get to the network as being a sensor. So if you guys in your research start to think about the network actually becoming a sensor for you, then you can add applications on top of that without having to necessarily put masses of sensors all over the place. The network, we hope, that's the research that we are undertaking. We hope that the network itself will provide information that can be used as a sensor. So there's a bunch of details there, but I think we're going to stop for now. But basically, those are kind of the summaries where we see that the 6th generation of mobile networks, the spread of that will finally get to a situation where we're actually able to provide augmented capability for people out of the network, as opposed to necessarily having to build all these separate, disparate pieces that go on top of the network. And that's all I wanted to say. So thank you very much.
Thank you. Thank you so much to Mr. Tim Nicholas for such an insightful address to the SARChi chair. Without any further waste of time, to the next speakers, in the interest of time, I'd like to humbly request that you please stick to your allocated time so that we can move with the program. The next address to the SARChi chair is by an alumni of Tshwane University of Technology and the French South African Institute of Technology. He will address the SARChi chair on the transfer learning in brain-computer interfaces. Ladies and gentlemen, please help me welcome Dr. Emmanuel Kalunga, the Head of Data Science and Business Intelligence from Order In. Thank you so much, Dr. Emmanuel Kalunga.
There is a pointer, and where's the next? Where's the first next? I guess. Should be there.
Yes.
Hello, everyone. Just wait for my presentation to go on the screen. In the meantime, I would like to, in a very special manner, thank Prof. Johnny for the invitation. I really feel good to be here. This is home for me. As I was introduced, I spent a lot of time working here, doing some research at the LESV and here at SARChi. And some of the work I'll be presenting today, some work that was initiated during my time at LESV and SARChi. So today I'll be talking about transfer learning in brain-computer interfaces. Let me test my pointer. Yeah, it works. All right. Can you for a moment imagine interacting with the physical world without using your muscles? If you could have an impact on object without touching them. Now, naturally, we use muscles. But using muscles might not be enough in some cases, or might not be possible for a category of users. As a matter of fact, you have people who have brain injuries, or some who have diseases like ALS, they lose control of their muscles. At the same time, they still maintain their mental capacities. Now, the question is there a way of assisting this category of people, even the general population, by creating devices that will allow them to interact with the world without using their muscles? And this is the promise of brain-computer interfaces. So, what is BCI, brain-computer interfaces? Brain-computer interfaces, at times called brain-machine interfaces, they are devices that allow human beings to interact with the physical world just by using the mental activities. Now, these devices, they usually, in this structure, as you can see on the image right there, they start by measuring the brain activities. And these are in the shape of electrical signals. And you do have different techniques to measure these brain signals. The very first one, which is the most popular, called EEG, it's the electroencephalography. You have electrodes that are placed on the skull of the user, and the brain signals are measured in that way. You do have other techniques that are a bit more invasive, where you have to place electrode inside the brain of the users. Now, these signals, after being measured, need to be translated into tangible actions. And for that, you use tools from signal processing and machine learning. And the applications that you'll end up having are either your normal computer applications, or you could use them for wheelchair control or exoskeleton control. Now, the promises of BCI are great, but researchers in this field are aware that there are a lot of challenges that still keep us away from using them on the street. And some of the common problems are, as I've mentioned, some measurement techniques are quite invasive. And the least invasive of these techniques, EEG, has a very poor spatial resolution. Another problem that is known in the field is the problem of BCI deficiency. You just have a category of people who don't manage to use these devices. And the last problem on which I will focus a bit for the rest of my presentation is the cost of sampling or collecting training data. I'll go deep on this. Now, that's a younger version of myself. When you need to translate these brain signals, you need quite a good amount of data, called training data. As for any machine learning practitioner here would know, you need a good amount of training data. Now, the size of data that you need is proportional to the number of channels or electrodes that are on your head, proportional to your temporal resolution and spectral resolution. These can get quite large. Now, to classify these brain signals into specific intentions, the signals that you are classifying need to come from the same distribution as the signal that you use for training. In other words, if you want to use the brain-computer interface on a person, then you need signals from that person to train your device. Also, you might need not only for the same person, but the same session, which is more or less the same context. Now, in BCI, it's hard to get this data. Reason being, as you can see on the picture, it's a very controlled environment and very strict protocols. Now, for a common user, I was using them in a very academic context where everybody was keen, these are science lovers, keen to do this experiment, but for your common user, they might not be very comfortable as they result in some sort of fatigue and lack of concentration, which will result in poor quality of data. Now, for user convenience, we don't want to do this. We don't want to spend a lot of time acquiring signals just for training. We want to have this time to be very short or not needed at all. Now, this problem could be addressed by transfer learning. Now, what is the idea of transfer learning? Transfer learning, the idea is given a set of data and their labels, data X and labels Y, from a distribution P, you can think of it as from a person lambda, you need to produce a classifier on a signal, on a data X and Y drawn from a different distribution. In my case, a different person or a different session. Now, the P is called the source domain, and the Q is called the target domain. So the source domain is the data that you might have acquired from a subject A, and the target domain is the new subject who want to use the device without having the time to acquire new training data or new brain signals. Now, so this is, again, as I was saying, part of the work that was initiated a couple of years ago. And we had an approach to this transfer learning. So you assume you have your brain signals represented by X. Now, this is a multivariate type of data. And you can have an assumption that they are normally distributed with a covariance sigma, which will be your covariance matrix of your signal. And then what you can do is use the sigma as your data or features to train your devices, your brain-computer interfaces. Now, one thing I would mention, but don't worry if you don't get that equation there, it's just, I'm trying to say that when you use these covariance matrices, they do not lie in a normal space like the one we're living in, but they lie on a very special type of curve, which is more or less represented by the graph there. And you can see when you're on a curve, it's almost like you're on the surface of the Earth. If you want to get a distance from here to Paris, you don't go through the Earth, you go on the surface of the Earth. So that's the geography, the concept I'm trying to have behind that equation. So then each EEG class become represented by the mean of that covariance matrix. All right, and then to classify, what you do is, if you have a bunch of data that belong to one specific class, you get all of them together and you get the mean value of that represent the class. And when I say class here, I mean a specific intention. Assume somebody is driving a wheelchair, they want to turn right. The action that they take mentally to turn right, you can consider that as one single class. The action that needs to be taken for them to turn left is another class. So that's what I mean by class. It's just what is the intention that the user has in mind. Now, so what we want to do with transfer learning is to say, if we have a subject who managed to acquire a lot of training data, can we use these data on a new subject? So what we want to do is, instead of doing that minimum distance to mean, by minimum distance to mean is, if I want to classify, I take my sample and say this sample belongs to the class whose mean is the closest. Now here we're going to use the same approach, but instead of being just a simple mean, it is a pooled mean. By pooled mean, I mean all existing data that you have about that class becomes a pool of data that you use to classify a new subject. Now, if you assume this in a normal space, what you have there in that equation, there's one thing that is of interest, is the lambda, which I could call the transfer coefficient. So what is happening here, on this side, you have your data, the sigmas of the new user. On the other side, you have your data from pre-existing users who have a lot more training data. So what you want to do is to use both, but by weighing them and saying, I'm going to use the data from the previous users to a certain extent that is defined by the lambda. And the lambda will vary from 0 to 1. If you say lambda is 1, then I'm using exclusively data from past users. If lambda is 0, then I'm saying I'm not learning anything from past users. I'll rely solely on the current user. All right, try again. And on this other side is the same principle, but just applied in the more appropriate space. So it's the same principle, so don't really go into it. Now, what we realize that if you use a pool min, which just says, take all the existing data and learn from that, we could improve on that by saying, instead of learning from all existing data, could we learn more from users who are probably more transferable? What I mean is, do I have users who have data that is very similar to my new user? So we kind of came up with a measure of similarity, which is just the inverse of the distance between the distributions of two different users. And that measure of similarity we're going to use to weight different, how much do different users contribute into the learning of the new user. All right, then that gives us an approach that we can call minimum distance to weighted mean. And if it has to be applied in the Euclidean space, it's the same as before, but there is this similarity coefficient there that will define how much are we learning from different subjects, depending on how similar they are to the new subject. All right, again, same concept, but applied into Riemannian space. All right, so what we get here, remember the idea is to say, I have a new user, you want to be able to use my BCI, but he has no time or no intention to spend time on training or collecting training data. Now, so what we want to do here, if you see on the graph, I'll just focus on one graph. They're all the same, but using different methods. On this axis, you have the lambda, which I called the transfer coefficient. And the n is the number of samples available from the subject or the user want to use my device. Now, a bigger n just means I have a lot of training data from the current subject. And the smaller n just means I don't have enough. If you check on this graph, the less n I have from the new subject using this method, I'm still able to perform and have quite good performance just by learning from previous subject. And if you see, the bigger my lambda, the bigger my transfer. So what I'm saying here is if you have a new subject who doesn't have a lot of data, just use data from previous subject. That can work. But if you have a large N, so your current subject is willing to train and collect training data, you'd rather use the data. That brings me to almost the end of my presentation, but I just wanted to mention some extensions and research opportunities. The extension of this, the work that I presented was focused on one single paradigm of BCI. There is more recent work done this year that extended this same approach to multiple paradigms, including motor imagery and P300, with very good results, proving that the approach is really helpful in terms of transfer learning. And then in terms of research opportunities, there are good questions to ask here. By the way, transfer learning is general. It's not just for BCI. Any machine learning might require transfer learning. Now, the questions become, what is the measure of transferability? How do I know that this specific user or this specific use case could learn from a pre-existing use case? You could use, like in this work, a measure of similarity or distance and divergences. But these are never good enough because the distance is symmetrical, but transfer is not. One subject can learn from the other, but the opposite is not necessarily true. So what is the appropriate measure of transferability? And what is interesting, if you can get a measure of transferability, you can determine your coefficient lambda, which says this is the degree at which this specific user can learn from a previous one. And that can help you save cost on your training data. For instance, you might know that in a specific area, it is easier and cheaper to collect data. So you collect data as much as you can. And if you have this value of lambda set, you will know that if I have to use this data for this specific subject, maybe the subject just needs to collect a few samples of training, and then using transfer, they will achieve very good performances. So these are all problems that I will be keen solving and collaborating on. Thank you.
Thank you so much, Dr. Kalunga. In this segment of the program, I'd like to call the Deputy Vice Chancellor, Dr. Vatiswa Papu Zamkaga, to come and offer gifts of gratitude. Over to you, Deputy Vice Chancellor, Dr. Vatiswa Papu Zamkaga. Firstly, I'd like to call upon Mr. Stephen, the Executive for Data Science from Telkom Group. I then call upon Mr. Tim Nicholas, the Customer CTO, Customer Experience Strategy and Technology from Nokia, South Africa. Thirdly, I call Dr. Emmanuel Kalunga, the Head of Data Science and Business Intelligence from ORDER-IN. Lastly, I call Mr. Armand Duplessis, Pre-Sale Solution Consultant from Siemens. Thank you. You can give them a round of applause once more. Thank you so much, Deputy Vice Chancellor. We are going to take a break. We are going to take a 15 minutes break. I'd like to request you to please make your way back in 15 minutes time. We're going to take a break. There are refreshments at the back. Please help yourselves to the refreshments. And also there will be technology demonstrations by the exhibitors. Please do visit and engage them on their technology demonstration. Enjoy the break. Thank you. We have 15 minutes. It's on my time. It's 2:15. We shall resume the program at 2:30. Thank you so much.
So you press the big button. And then your point of direction should be that side. Back.
Okay.
Yeah. So you can either look at it there or look at it here from the screen.
Okay. Very.
We will proceed with the program in a minute's time. Please conclude your refreshments and engagements. We are going to continue with the program. Please make your way to your seats. Thank you so much. Those that are joining us online, welcome back. We are resuming with the program. Welcome back to those that are joining us online. We are continuing with the hybrid seminar. Welcome back to the SARChi chair in Enabled Environment and Assistive Living Research and Innovation Seminar. We are continuing with the program. There's a few changes. If you turn your attention to the program, there is just a slight change to the program. The next speaker will be addressing the SARChi chair on data platform for IoT and ML ops. Ladies and gentlemen, please help me welcome Dr. Mohamed Hilia from IPON Technologies. Dr. Mohamed Hilia, IPON Technologies. Thank you. You have the pointer.
Thank you very much. So, can begin? Okay, good. Okay. First, thank you for the invitation to be part of this seminar. Today, I will share with you a success story about collaboration between an industrial partner, IPON Technologies, one of her members, and SARChi and UPEC University. So, let me introduce myself. My name is Mohamed Hilia. I'm data solution architect from IPON Technologies. We are a consulting company on data and cloud technologies. I'm expert on the cloud technologies and on symbolic AI, and also I have some expertise on distributed systems. So we all agree about that. Today, the number of IoT devices are increased, and the number of all of these devices are generating more and more data. Another aspect of this concept is that the IoT devices have more computing capabilities. And in a lot of studies, we say that is a fact that we have more data volume that should be analyzed to get value from that. For example, we see the last IDC report that volume of data in 2025 will be in zettabytes. We have now an opportunity to explore and analyze all of this data. We have more volume, so we should analyze and explore this data to remain competitive in the market. So it's a real opportunity for the business companies. The artificial intelligence in the other side is a means to create value from all of these companies, to create more valuable services and products. So it is important for us as an industrial partner to get this shift and offered by the IoT and the edge computing capabilities. Besides all of that, we should benefit also of the managed services offered by all the cloud providers, such as Amazon Web Services and Google Cloud Provider, and all of the new architectural patterns, such as serverless and containers. With containers, for example, we can build once and run everywhere. We should also see and acculturate our teams on all the automation stuff, such as DevOps cultures. So in EPON Technologies, we say that now we are facing an opportunity is here, and we say, how can we take advantage of it? We have several objectives, and I will in phase 3 of them. We should prepare our consultants, our teams, to be effectively prepare our teams to the tomorrow technologies and realize something that we see. It's all of the proof of concept today are not going to production level. And these 2 points will generate more business opportunities, thanks to the dynamic of the innovation. Since this concept, we say how we can proceed. And the first thing that we have done is that we build a first research collaboration with SARChi and UPEC University. So in EPON Technologies, we are data experts. So we build data platforms in the cloud every day. We are specialized in data engineering and data architecture. We design and implement data strategies. And for the other aspects, we don't have the maturity to address these topics, such as AI aspects and the IoT, especially the hardware parts. So we decided to go in a collaboration with SARChi and UPEC University because of 2 points of the maturity of AI landscape of our academic partners. In EPON Technologies, we have several convictions. The first one is that we don't build data platforms without have use case first. For example, we don't build data lakes or data hubs without having a use case that drive these innovation initiatives. The second conviction is to keep simple our architecture. A simple architecture is more maintainable and it's rapid to be adopted by our client. The third of our conviction that we design all of architecture for tomorrow requirements, for today requirements and not for tomorrow. And the last one, which is not possible for all of our clients because of the privacy of the data, we recommend to use cloud first. So we have several convictions, and we decide with SARChi to create a unified platform for the innovation. To remain faithful of our convictions, we started with 2 use cases. The first use case is about the effective computing, so that we collect the data, and we predict the emotion of people. The second use case is about recognition and monitoring people activities. To give you more details about the first use case, 3 aspects of every use case. So we must collect this data and build the model. The first one, the data was public, because to get the sensitive data to effective computing is very difficult today. The data is unstructured, mainly unstructured data. And with the recommendation of SARChi, we have not collected a lot of data. So data augmentation was a must to do. The model was developed with SARChi, based on neural network. And as Econ Technologies, we build all the stuff to industrialize the neural network and get it to the next level. When I say the next level, so all the aspects of automation, the scalability, and the monitoring of models in production. For the second use case, the data has been generated in LISI laboratory of University of Paris-Créteil. The data has been generated from 5 accelerometers, and they developed, the data scientists in the laboratory developed five models. So our contribution as Econ Technologies is to industrialize all of the models and automate and scalability of these models. Now, I will explain some foundation of what is data platform, what is the building block of this data platform. In 2 words, a data platform is to handle the life of the data from the ingestion to the visualization part. The ingestion, to collect the data, the storage of this data, if it is structured or unstructured, how to explore and the tools to explore this data, and to transform and process this data. For the vertical aspects, we have the governance parts which describe all the data that we have in our data hub. What we do in this work with SARChi, that we extend what we have the ability to do every day with our clients, and to extend to more operational of machine learning models. So we extend to the platform to accelerate the AI project and to get all these models to the next level. This consists of the automation of the platform, the management of the logistics of machine learning parts, such as versioning all the data set, that is the training data set, versioning also the models that are produced, and have a history of all of this stuff. The last thing is about the provisioning of this platform and to be reproducible for several teams. What we built on this data platform for the ingestion part was to integrate 5 devices: the camera, accelerometer, that are supporting several protocols, and we will see how the global architecture for the ingestion service. And we planified to integrate other devices. To go in more technical aspects, this is the architecture. We say that we have in the left the integrated devices. They are stored in Amazon S3, which is a block storage to get all this data in secured manner, and the IoT core, which manage the authentication and the authorization of all the devices. And on the right side, two tools for the visualization and the governance part. So we see that our architecture should be scalable. So all our Amazon EC3 that are exposing services to be used in publicly are spread over 3 availability zones. We see that. Sorry. Oh. So all the instances are spread on 3 availability zones. So if we lost one availability zone, we have an architecture that is resilient and fault tolerance. So for the next actions with SARChi and IPEC University, we will work on research direction. For the first use case, we have problem to get data. So this data is privacy and confidential. So we explore techniques such as federation learning to perform training without copying data in our cloud data platforms. And the quality of data using machine learning techniques is another aspect of our research directions. We have also some engineering improvement to do, such as implementing a data catalog to describe all the data that we have in our data platform, to add some automation stuff, such as infrastructure as code, and streaming capabilities to get the data from the devices. Thank you.
Thank you so much, Dr. Mohamed Hilia. In this segment of the program, we are going to continue with the address to the SARChi chair. The subject is hybrid approaches for context recognition in ambient assistant living systems. Ladies and gentlemen, this segment of the address will be done by Dr. Abdel Kewi, who is from Toyota Motors Europe, and he will then be addressing us online. Let us welcome Dr. Abdel Kewi. Thank you.
So, can you hear me clearly?
Yes, we can hear you. Thank you.
Okay, thanks so much for the reminders. And today I'm going to present the presentation titled Hybrid Approach for Context Recognition in Ambient Assisted Living Systems. I will start with the outline. So during this presentation, firstly, I will explain the context and challenges for this presentation. Then I will As you can see here, we have textual sensors, we have audio streams, and we have audio-visual stream also. And we started to train our own neural network and combine it with the detected modalities and the extracted features to detect the human emotions in real time. But as you know that machine learning, it is not that much accurate, and that's why we already used here a higher level reasoning to infer and to estimate the human emotions over time, and also to infer the implicit emotions. For the features we already used, it is the 3D facial key points. Also, we used some gender features, age and race. For the audio features, we started to use something like a null frequency spectrogram. And for the textual features, we used the word representation, the standard ones, actually. After that, we already used the normal neural network to fuse all of the current features. And we finally succeeded to detect 9 different emotions like anger, fear, happiness, neutral, and surprise. For the higher level reasoning, we used actually the knowledge representation reasoning based on some ontological representation for human emotions, as you can see here. And we use the narrative knowledge representation language to do the inference of human emotions over time. And this is like an example of the inference rules that we already used. And to evaluate the system, actually, we already obtained the state-of-the-art results, as you can see here, by 91% of the accuracy of the presented models. And for more information, you can visit the highlighted publications. We already succeeded to detect the contextual human emotion recognition like curious, confusion, upset, negative and positive surprises, and dislike and like. And those emotions are really hard to be detected from standard data sets. And this is actually the result of combining reasoning and machine learning models. As you can see here, the contributions actually is developing a hybrid contextual emotion recognition system for assistive services. Also, we presented the contextual emotion recognition and management, which is able to recognize the non-observable emotions. And also, we created a real-world use case in EmoSpace European project. For the conclusions and perspectives, here actually we aim to define and to develop a multimodal human emotion recognition that combines the low-level features and high-level features. Also, we succeeded to detect and recognize non-observable human emotions. And finally, we already applied that in real-world use cases. For the perspectives, I think that for the short term, we aim to include more modalities like EEG and facial action units. For the midterm, actually, we are trying to handle the gap between the machine learning and reasoning layers. And in the long term, we are trying to apply more automated reasoning to handle the real-time corner cases. Thank you so much for your attention. Thank you.
Thank you so much, Dr. Abdelkarim. The next address to the SARChi chain is on the subject of future-proof digitalization, and I'd like to call upon to the stage Mr. Armand Duplessis, pre-sales solution consultant from Siemens. Ladies and gentlemen, let us welcome Mr. Duplessis. Thank you.
Afternoon, ladies and gentlemen. Can I please ask my IT friends at the back to please play the video?
Today is an incredible day. The industrial world is in the midst of transformation, and never before has the pace of innovation moved so rapidly. The digital future of industry is no longer some far-flung promise. Today, today's products are becoming smarter, more personalized. They're becoming intricate systems of systems, challenging you to harness layers of complexity and data, blurring the boundaries between physical and digital domains, and comprehensive digital twins that represent and validate what is possible are not optional. They're required because they allow you to find new levels of efficiency and performance that are hardly imaginable. New insights, new opportunities, new levels of automation at every point of the value chain. This value chain, this digital enterprise is where engineering meets tomorrow. It's where manufacturing meets tomorrow. It's where electronic design meets tomorrow. These aren't the promises of tomorrow. With Siemens Digital Industry Software, they're the opportunities of today. Siemens Digital Industry Software, where today meets tomorrow.
Much. I'm just waiting for my slides. Let's see. There we go. First of all, I'd just like to thank TUT for hosting us. We really appreciate it very much, as well as Dr. Nico for being our point of contact. We really do appreciate it. I'm Armand Duplessis. I'm the pre-sales consultant at Siemens. When people ask me, Armand, who do you work for? I tell them I work for Siemens, because if I tell them the longer version of Siemens Digital Industries Software Solutions South Africa, it takes a while to get the conversation going. So when I tell them I work for Siemens, the first question I get is, don't you guys produce something? Don't you make medical devices? Don't you make trains? We make all sorts of things. All kinds of things are manufactured by us. And my answer to that is yes, we do manufacture all these things, but not us, some of our brothers and sisters in the sister companies. So let's maybe start first by who is Software Solutions that we work for? Okay, so if you look at the top, you can see that at the very top, we've got our holding company, which is Siemens AG. At the bottom of that, we have multiple different sub-holding companies within that. First, we have Smart Infrastructure, Mobility, Siemens Advanta, portfolio companies. A lot of the manufacturing facilities sit in there. And then we have Siemens Healthineers as well. So for those of you working as doctors or vets, you will recognize our scanning equipment in your laboratories or hospitals. That comes from the Siemens Healthineers. So we fall under digital industries on the far right-hand side. If you look below that, there's a bunch of other companies. Okay, so we've got factory automation, motion control, process automation, and customer services. And then you get us, which is Siemens Software, right? Now, as I've stated that Siemens has manufactured, historically it started with manufacturing, but something happened along the line. It became harder and harder to compete in the industry. And Siemens realized they needed to change something in their factories to be able to compete at a global scale. And so what they did was they created software, which is us, right? And in the process, it was opened in 2007. And from there, they started acquiring companies. To be exact, they acquired $10 billion worth of investment in different companies. I believe every 2 or 3 months, I get an email of a new company that we've acquired. But why did they do this? Well, first of all, okay, there we go. So first of all, there was complexity. Okay, in the world of manufacturing, we had a bit of a problem. You know, in the old days, it was good enough to work from 8 to 5, Mondays to Fridays. But now we're working 24 hours. Okay, we're working Mondays to Sundays. The consumers are expecting more in this digital age where we're connected to everything through the internet. They want to be able to open up their app. They want to be able to customize their Nike with their name and their colors and their brands and everything they have on it the way that they want it. And they want day one delivery in the next 24 hours, right? So with the rise of the internet and the fourth industrial revolution and all these different things, it has connected us globally and it has opened us up for fantastic innovation. But the problem is the complexity has also risen to a completely different level. In the past, it was good enough to just have your Ford Bakkie. Now it's not good enough anymore. Now you need to have it in different colors and in different schemas, the way that you want it specifically. So that's made manufacturing specifically very hard. And that's exactly why Siemens bought the software company, because they realized it's not good enough for them to create prototypes and then deliver those prototypes to manufacturing lines and then find out 6 months later it doesn't work anymore. Because in reality, if you think of a mobile device, its lifespan is roughly 6 months, actually. Although we have our cell phone contracts for 2 years, now it's expected that every 6 months you can upgrade very quickly into something new. And this is really where we as software compete. This is where we bring our value proposition to the table, is that we realize that in the real world, that's where your ROI is at its biggest. That's where it's most complex and it costs you the most to create a prototype and put something into the line. So what we decided to do was to create a software division where you can fail in the digital world, and you can fail as many times as you need. The cost of failure is as much as your software costs you, but you want to be 99% sure that the moment you put your product out in the line, out into the world, that it's going to work. And with that, they created their portfolio. So at a very high level, what Siemens did was they decided, listen, all the way from idea, all the way from ideation, all the way from prototyping your product to conceptualization, all the way from actually making, maybe 3D printing your product, and then taking that through to the line. You know, after that, you typically have your startup, then you have your manufacturing, and then you have your maintenance, and then end of life. Okay, so that's what Siemens supports, the software division, the whole life cycle, cradle to grave of your entire product. In theory, we can support your product all the way from the idea to the moment you decommission your product, even without you having any company, even without you having any prototype on any line. There we go. So software competes at 3 different levels. The first value proposition is, listen, we need to have a comprehensive digital twin. What is a digital twin? Well, if you have a real world replica of your product, then we need to have a digital representation of that product within the software space. Why? So that we can change it, so we can test it, so we can interrogate that product, so we can see, listen, under different stresses and strains, this is how your product is going to relate, and this is how it's going to behave. What we mean with a comprehensive digital twin is all the way through from the moment your product is created. We want to go to the deepest level of nuts and bolts of that product that you have. And we realistically want to simulate that thing. In essence, the moment you create that product out in the field, we want you to be 99% sure this is the thing that you've created. Right? There might be a slight variance out there that's something that you didn't think of, but in essence, we want you to be able to, in a controlled environment, design your entire product. Then we have personalized, adaptable, and modern. Many companies are at different levels. We're talking here about research, startups, but from our side, we come from the industry, right? So we're talking about the automotive industry, where we have large volumes of products being created. Now we have small companies on the one side and larger companies on the other side. Not every person or every company's need is the same. So some researchers and startups have a smaller entry point that they need, and they need very specific tools to help them. And so that's why our ecosystem is open, right? And that's the last part really, is we have a flexible open ecosystem. The idea really here is that we don't want to be like iPhone. If you don't have an iPhone, you can't talk to anything else. Really, we want our software to be able to talk to any other piece of software that you have. If you have some kind of MATLAB program out there, we want you to be able to program it and push it into our plant simulation software, and then have real-time feedback back into your MATLAB products. Outside of that, the next phase that they have, outside of that entire portfolio of products that we have, is they decided that, listen, we need to go cloud. That's something that we've talked about today a lot, is a lot of people have talked about the cloud and connecting up. But the reality is we're not there yet. In South Africa, a lot of companies don't want to move that way. And not every company has the same need. Not every corporation has the same need. So what we're doing is we're trying to provide different solutions at different levels. And what we're finding is that people are coming in with hybrid approaches, right? So some people want to go full SaaS. Other people want to have on-prem systems. If you're thinking about military installations specifically, these guys, they don't want to be connected to the internet at all, okay? And it depends on what you need and where you need it. But the idea is that you can slowly onboard onto the cloud. Obviously, there's a lot of advantages to be on the cloud, and we partner with AWS for our cloud solutions, right? So all of our systems sit directly on the AWS systems. But historically, on-prem solutions have been the way to go. So here we can see a full stack. I've talked about the different products that we have, or at a very high level, because we've got hundreds of products and I don't really want to show all of that. But I've said previously that we have, historically, we come from a manufacturing point of view, right? So that's where we were. And then they realized, listen, we need to connect up to PLCs. And then we have to go from the PLCs, we have to pull all our IoT data into the cloud, right? And then we have to do something with that. So as we stand here today, Siemens has a full stack that you can connect up to, from all the way from your hardware to your PLCs, all the way to MindSphere that will suck up all of your data. And then we have our rapid application development, which is Mendix, which was acquired about 2 years ago, I believe. And that's a way for us to, in a world where everything's getting more complicated and you need a way to rapidly move between different software solutions and have an agile approach to how you extract data from one area into another area. Mendix really gives us that flexibility. Okay, I'd just like to end off with, I just put this slide in there because, I really want to emphasize that we have an open ecosystem. A lot of software out there is kind of black boxed. And when you move in there, if you don't have a specific file type, you can't export it, you can't pull it in somewhere. And realistically, we're talking about future-proofing. The technologies and stuff that we're talking about here today, that everyone has presented here today, not all of us know what's going to happen tomorrow. We didn't know about COVID, right? And the technologies that it would push forward. So when you're talking about the software that you're using to push your company forward, realistically, you want to use a base of operations for your software that will help you to extend beyond just that software. You don't want to be locked into place and move somewhere else. And I'd like to just end off by saying, we've seen a lot of technology here today, a lot of interesting research that has been done. But the question I really want to pose to each and every one of you here is, in 5 years' time, how many people have been affected by that technology? This morning, there was a number that was raised for the assisted living. I believe it was 10 million or something like that. Can you touch that amount of people, 10 million people in 5 years, right? And really, that's where we see our value proposition, is industry has the means to directly connect to the end client. But institutions like TUT, that's where the ideas come from. That's where the advancements and the research comes from. And that's really where things are pushed to the edge. However, sometimes there's a little bit of a disconnect. And we see ourselves as the bridge between research and all the way to industry. Why? Because that's what industry uses. They use our software on a daily basis. What a lot of people don't know is they think a lot of people think that, engineering is still done on pen and paper in the background, but that's not how it works. If you take SpaceX, those kinds of things, those people, they do rapid design prototyping. They've probably done a few thousand prototypes in some kind of CAD package before they even touch the physical prototype. You can't compete with something like that. And so the real question that we want to bring is, those ideas that you have, ask yourself this: who am I touching by my ideas with my research, and how am I going to reach a bigger audience? How can I bridge the gap from making one wheelchair, and how do I mass manufacture that so it can be in 10 million homes in 5 years' time? And if you want to know more about that question, please come see us. We'll chat to you and we'll help you guys out. Thank you very much.
Thank you so much, Mr. Duplessis. Ladies and gentlemen, we are in a hybrid seminar, and so the next speaker would then address the SARChi chain online on a pertinent subject outlined as the artificial intelligence for an augmented diagnosis on pathology. Ladies and gentlemen, let us welcome Professor Julian Calderado, Associate Professor, as well as University Hospital Practitioner in the Department of Pathology from Henry Mondor Hospital. Over to you, Professor. Let us welcome Professor Calderaro. Thank you so much.
Thank you very much to be there, at least virtually, and thank you, Karim, for this kind invitation. So I will discuss the interest and the potential power of artificial intelligence for pathology, and you will see what, as an academic, I expect from this kind of technology and how it can help us to improve the diagnosis that we perform every day. So, as a pathologist, our jobs is to look at cells, at organs. Every time a patient has a biopsy or has a tumor that is removed by a surgeon, then they send us the tissue and we process it with different chemical reagents, and then the tissue is put on a slide that we look with a microscope, and we look at the appearance of the nuclei of the cells. We look at the overall architecture of the tissue, and we are supposed to say what disease it is. It is a cancer. Is it an aggressive cancer? Is it a benign tumor? Is it a non-neoplastic condition, autoimmune disease, and so on. And we also perform prognostic systems based on the appearance of the cells to predict the risk of recurrence and therefore the potential need for adjuvant therapies. In pathology, the use of AI is possible due to an ongoing revolution of our practice, which is digital pathology. So I told you that classically we look at slides through a microscope, and these are glass slides, but since approximately 15 years, there are some devices that allow to scan these glass slides, and they transform these slides into a digital file, and you can view the slide on your computer. As you all know, an image is a matrix of number with the intensity value and also the spatial location of the pixel. And for pathology, we look at colored images. You have an example here of an image of a liver cancer. You can see the nuclei of the cells, the cytoplasm, so it has different color. And this image is, for example, encoded in RGB. That means you have 3 matrices, one in red, one in green, and one in blue. And the image is the result of these 3 matrices. So when we scan a histological slide, we obtain a file, a big file, that is about between 2 and 4 gigabytes. So it's very large data. For example, in my department, in Université Paris-Créteil, Hôpital Henri Mondor, we produce every day around 1,300 slides. So that gives you an idea of the amount of data that we generate. And so far, with the deep neural networks that we use to process these images, we have to cut the slide, the digital slide, into small images, and this third process is called tiling. And then, so I will not go into detail. So I think you know that, and probably better than me. The process is to take these images and these three matrices in red, green, and blue to extract numerical values from these images, and then we put these images into layers of different convolutional neural networks. And what we do usually is that we aim to predict something that is clinically relevant. For example, we can automate diagnosis, we can predict the existence of a particular mutation in the tissue, and so on. We can also predict the risk of death after surgery and things like that. And so since several years, there is really a revolution in pathology with the development of models that aim to automate diagnosis, to predict prognosis of the patient using the slides, and also to predict from the slides some molecular, some biological features that are used, for example, to give particular treatments to the patient. So when we look back from an historical perspective, it's not so recent, the use of automated image processing in pathology, and there are several softwares that allow to analyze smears, cervical smears. You know, it's the kind of exam that is performed to screen for cervical cancer. So this is an exam that is kind of boring to look at. We get a lot of these exams, so it's typically a good indication for the development of models. And there are some labs that use software that pre-screen the slides, and the pathologist only has to look at the slides that are tagged as abnormal. And in this line, several companies have now developed diagnostic assistant, and in particular, this assistant that aims to automatically detect prostate cancer has recently been approved by the FDA as a diagnostic assistant. So prostatic biopsies are also kind of boring to look at. There are lots of biopsies. Sometimes it's difficult. You can miss a cancer. And what does this software do? It pre-screens the slides, and then you have a heat map. And for example, you have a color code with the probability, with the output of the model. And when it's yellow, the model, for example, is 100% sure that there is cancer. And so you can be sure not to miss a cancer when you review some biopsy from a patient that is suspected to have prostatic cancer. So there are lots of companies now that are developing this kind of application softwares. We will see how far we will go, because for diagnosis, we need to be 100% sure of the software. I think we can't allow any mistake. So we will see if there are other organs where it is possible to automate diagnosis, but there are many studies ongoing, and I think this product is the first of many more. What I think could be probably even more interesting is to develop these AI tools to automate the prediction of prognosis. So I told you that when we review the slides, we look at the cells, the nuclei of the cells, the way they look, and it gives us information on the grade of the tumor. So we can say probably the patient that has this tumor will have a tumor recurrence very soon, 1 year after surgery, for example. And we use this data, for example, to give adjuvant therapies to limit the risk of recurrence. And the system that we use so far for this kind of prognostic prediction are far from perfect. We are able to identify classes of risk, but we are really far from perfect. And I think that's typically the field where AI can help us improve the prediction and also standardize the prediction, because the problem also with human pathologists is that there are problems of reproducibility. You know, the human eye, if you look at a slide when you're tired or in the morning, there could be variation. And also if a colleague of you look at another slide, he may have another opinion. So there are discrepancies between observers. And the interest of AI is that it will allow to always give the same answer when you process a slide. And I will present now a study that we performed at UPEC, Université Paris-Créteil, in collaboration with Assistance Publique Hôpitaux de Paris and also company, Okin. We aim to predict the survival of patients who had liver cancer and who underwent surgery for this liver cancer. So briefly, we developed the model from patients from Henri Mondor Hospital, and the model was validated externally on a public data set of patients. It's a public database that is free to access with clinical data, follow-up, and also the digital slides. So the overall workflow is that we go from the surgical specimens of the liver cancer, we obtain the conventional glass slides that we use in our daily practice, we scan them into these digital files, and then we put these digital files into the networks along with the survival data. For example, this patient is still alive 10 years after surgery, or this patient died 6 months after surgery. And what we showed, so I will not go into too much detail into these figures, but briefly, the deep learning models that we developed were able to predict the survival patient more accurately than all common features that we use in our daily practice. And even when we combine all the classical features that we use in our daily practice to predict prognosis, it does not reach the performance of our AI models. And you have the example here with the survival curves of the patients after surgery. And you see that this class of patients, which are designated as high risk, have a much higher risk of death after surgery. So briefly, we also validated these results in this external series of patients. It was slides that were encoded in a different format with different stainings. So we really wanted to do a real validation. And we were able to show also that using our classifier, we were able to predict the prognosis of patients. But probably what is as much important is the analysis of most predictive areas. So you all know that we say that AI is black box, deep learning neural networks are hard to understand, so that is true. But these kind of models, they allow us to go back to the slide and they highlight the areas that has the most impact into prediction. So basically what we can do is to know which part of the slide had real impact into the classification. And we were able to review these styles by a pathologist, and we showed that there were some particular features that were associated with high risk of death. Some were already known and some were new. So I think this is a very important part, because it will be difficult, in my opinion, in the future to have completely black box models for AI, because it will be difficult to tell a patient, for example, we won't do, for example, any chemotherapy because your disease is too advanced, and because the model has said so. We don't know why, but the model has said so. Now, what happens in the practice is that you tell a patient that unfortunately he may not get another treatment because his tumor is too large, or because he has metastases and things like that. So we need to understand our model and how they work if we want them to be accepted both by the clinicians, the physicians, and the patients. And apart from prognosis, what is also a very interesting perspective is the use of AI as a biomarker. We use in our common practice a molecular biomarker to know if a patient may get a particular therapy. For example, we assess some mutations in lung cancer, and if the mutation, the genetic mutation is there, we are able to give a particular drug to the patient, and patients that do not have this mutation will not respond to this drug, so we do not give the drug. And it's important also because these drugs have important side effects, so we spare the patient that will not benefit from the drug. And these biomarkers, they require an expertise in molecular biology, and in bioinformatics, you have to extract the RNA or the DNA from the tumor. It takes a long time. It's costly. And some teams have showed that when you process the slide of the tumor, you are able to predict the molecular alteration of the tumor. And it has been done noticeably by the team of Jacob Katter, who has published some pioneering studies in this field, and he reached a really impressive performance of 0.96 for the prediction of a particular alteration in colorectal cancer, and this alteration has a particular impact in treatment. So we need now to validate prospectively these models, but I believe that this kind of approaches will have a role to play in a foreseeable future. And I will end by one study that we did and that is not published so far. And we tried to predict using the slides also and using different neural networks the status of the anti-tumor immune system of the patient. And we looked at the cells, the immune cells that are within the tumor. You know that when you have a cancer, your immune system tries to fight the neoplastic cells. Often, unfortunately, it fails. And there are some new treatments that foster your immune system and that allows your immune system to kill the neoplastic cells. And we know that these treatments are particularly effective when your tumor is deeply infiltrated already by immune cells. And we took slides of liver cancer also, and in liver cancer, there has been some gene signatures that reflect the presence of immune cells that predict the sensitivity to an anti-PD-1 antibody, which is an immunotherapy agent. So we developed the model in 350 cases, and we validated the model in 150 cases from our hospital. So what we did is that we studied the gene expression. So here is a clustering of a gene expression. It's the gene expression 6G interferon gamma. It's an immune gene expression. And then we trained the model by giving him the slide and the label. Does this tumor express these genes or not? And we were able to reach a good performance with AUC, for example, of almost 0.9. And we validated these results also in our external series. And again, what is important is to have a feedback on how the model works. And for that, we are able to generate attention maps. That mean this is the tumor at low magnification. Also, another case is here. And you can see here we tested the gene signature T-cell exhaustion. And the areas that are in red have a high impact in the decision of the model. So we can look back at these areas and try to see what cells are there. And we can do the same, for example, for this signature and other ones. So it's all these technologies are obviously very exciting, but we have to remember that they need to be prospectively validated and they should be rigorously evaluated. And as rigorously as other diagnostic tests, there will be some guidelines to establish this kind of test. Probably the biomarker field will be more rapidly implemented because for the diagnosis, you won't allow any error. And these also type of approaches have ethical considerations because it questions our relationship with the machine and what amount of things we are eager to delegate and what we want to delegate, because we have to keep also some knowledge to interpret the results. And that's why I think probably in the next 5 or 10 years, we will have what we call augmented pathology. And for example, this could be an augmented pathology workflow with here a pathologist. She reviews surgical specimen of colorectal cancer. She has the slides. And then she selects the model that she will apply on the slides, the detection, for example, of metastasis, of vascular invasion. She will also run some prognostic score. And then at the end, you will have a hybrid report, composite report with the conventional pathological report, with we state the tumor, the degree of infiltration, the differentiation, but also the results of the genetic predictions. And also, what you have to remember, but you know all that, is that model can go completely wrong, and it's particularly a problem with health data. Because you know on the Google website you can upload an image and the model can do a prediction. And for example, I uploaded an histological image of a liver disease, and the answer was a Mexican restaurant. That was the output of the model. So it's just a joke, but it's just to show you that the model can go completely wrong. And so far, you don't know really what happens within the model. So that's a problem. And it has legal implications also. So we really need to have inputs on how the model works if we want to trust them, at least for application in health science. So I will end by thanking all my collaborators from the hospital, from the university, also from Centre de Recherche des Cordeliers. Again, thank you, Karim, for this very kind invitation. And also, I would like to say that we are setting up at UPEC an educational program on the use of AI for pathology. There is this website where you can have information, and we are planning educational modules and hands-on session if you want to practice or to know more about that. And you can send me a mail if you want further information. Thank you.
Thank you so much to Professor Julian Calderaro. In this segment of the program, we have come to the last keynote address to the SARChi chair, which is again going to be online. And we are joined by Dr. Roxana Ojeda, who is the CTO of COMSYS SAS France. And she will address us on the subject of COMSYS and FISATI 802.11 protocol design and FPGA implementation. Ladies and gentlemen, help me welcome Dr. Roxana Ojeda. Thank you. Over to you, Dr. Ojeda.
Okay.
Yes, we can hear you. Thank you.
Yes. Do you can test the timer, please? I can do it.
Apologies once again for the technical glitch that we are having. Yes, we can hear you, Doctor. Yes, thank you so much.
I designed the consistent line and the collaboration with the second. We have working together in the design.
Ladies and gentlemen, I apologize for the technical glitch that we are experiencing. You'll come through. Thank you. Apologies.
No, you're welcome.
Apologies there.
I take over. I will present on behalf of COMSIS. This project is about the design of an IP related to 802.11ah for the Hello Wi-Fi. It seems that we have troubles to get Dr. Roxana Ojeda online. I explain what COMSIS is about. COMSIS is a company, a French company, that started in 1995. They initially were working in GSM era. They were creating IPs for cellular communication. They are now part of a group that is named AF1. From 2006 to 2011, they developed their main core business, which is based on a platform, the design platform that we did some engineering together on that platform. It's related to IP in MIMO Wi-Fi. Okay, massive MIMO Wi-Fi. And their business actually, from 2013, 2016, they provide IPs to the integrator, to industry. That's what they do. Mainly they provide an physical layer, which is the MIMO Wi-Fi, also with the MAC layer, as IPs to be integrated in chipsets by the OEM. So they cover a set of technology that goes from residential access through Wi-Fi with quality of service assurance, VUID, VUIP. They have some patent in security background related to channel control. And then they do research related to Cloud RAN and 5G and beyond. All what you need to do in signal processing and development of physical layer when it comes to sizing or developing physical layer for cellular, like 5G and beyond, but also for Wi-Fi. Their strength is in Wi-Fi. They do solution for vehicle communication, vehicle-to-vehicle communication, and vehicle-to-infrastructure communication. They also do industrial robotics and IoT. That is one of the scope that we work together. We have been working together on long-range communication for rural area, and we work together on this Hello Wi-Fi for proof of concept with quality of service assurance in massive IoT. So, okay, let me get back. So I will not go through all of that. They start from the Wi-Fi B in 2.4G, and then they move to 5G, the N, the P, which is for vehicle to vehicle, and then they have the AD, the AF, they have different set of protocols. The aim is to get to AX, which is this next generation Wi-Fi for industrial communication. I will not, there is a lot of things they do. They provide
source code in VHDL and Verilog, and also for FPGA and ASIC, but also they provide what we name SOC system. They provide C programming and full stack for integration with chips for industry. Okay. This is their list of patent, and this is our scope. Why we do the AH in the Wi-Fi. If you look to the technology, I will not. LoRaWAN and SIGFAS are not standardized standard. They exist in industry, but there is low power, low data rate technology. They cover set of market, but that's not the main market for IoT. The market is going narrowband IoT. That's where the telco operator stands. That's where we found the contribution. But in between LTE-M, what we machine to machine, and the standard N, we find this Wi-Fi that can, with probabilistic access, that can be a possibility to large scale or scale it up in the Internet of Things. If you look to IoT in cellular network, the principle that behind it is that when you have a network like LTE, when you decide to deploy IoT network within your cellular network, you have to provision a frequency band, which is around 200 kilo for your IoT application. You can do more, but this is the basic for you to have the access on the radio, and then you have your core network that support the IoT or all your objects that are not your mobile phone, all your objects that are related to Internet of Things. What is interesting why we choose this technology, because you can have data rate that are much bigger than what you can get on narrowband IoT. The low power and the low data rate are one side, but what is the main market is on narrowband. What we are targeting is to be complementary in this hybrid era where you can provide solution for class of application. You can go lower than 1.5 kilohertz, but we can get more if you are in sub-gig gigahertz. Okay, there is few drawbacks related to energy and power consumption when you come to energy control, but Wi-Fi is doing well. It will be a complementary solution for the cellular network. Okay. We did in our previous collaboration within a COE, Telcom COE, we did do a backhaul based on Wi-Fi. What we in the sub-gig, we can go more than 10K. We can validate in line of sight. We did experimentation here in TUT with ComSys. This one is, I don't know where they did it, but they did this backhauling that you can use in the payload, which is 50 megabits. Okay. When you talk 5G and you talk to this, it seems like it's not the edge, because we are moving to another level of technology. But that's what we did in the past. Okay, the Wi-Fi application are in industrial context. If you have a large number of nodes that you have to connect and you manage quality of services, if you are able to develop the set of protocol that on the top of a probability access protocol, you can manage to deliver quality of service for your Internet of Things. So that, like smart industry, transport, and so on, healthcare, and different set of technology. The collaboration between the ComSys and SARChi at TUT is based on using this MIMO Kit 2. It's shown there in the cubicle. We have either you go Altera technology or Xilinx. It doesn't matter. It depends on the FPGA you are using. Actually, we are using analog device for the radio channel. What we basically develop is physical layer. Is a part of the MAC layer that is developed. They're busy there to do research on finalizing the MAC layer. We have PhD students that working on this virtualization of gateways for the Wi-Fi on the cloud. It's Prosper. He's around. He's developing algorithm that can scale it up for industrial context. Okay. That's it. Roxana is the Chief Executive Officer. She is doctor from Ship Telecom Paris, and you can join her if you have any question related to their business. Thank you very much.
Thank you so much to Professor Giovanni for standing in for Dr. Roxana Ojeda. That concludes the keynote addresses to the SARChi Chair in Enabled Environment and Assistive Living, Research and Innovation Center. At this segment of the program, I'd like to therefore call Dr. Kanakana Katumba, the Executive Dean of the Faculty of Engineering and Built Environment, to come and do the closing and the vote of thanks. Dr. Kanakana Katumba, over to you. Thank you.
Sure. Wow, what a day, eh? Good afternoon, ladies and gentlemen. You're too quiet. Are you okay? Are you tired? Was it information overload? Oh, okay. So, colleagues and all protocol observed, ladies and gentlemen, thank you, Program Director, for directing the work so well until now, when we are at the end. It was really an exciting day. I'm really excited to be here. But let me deal with protocol first. So allow me to recognize in their absence, the VC and the Principal, Prof. Van Staden, the DVC Research and Innovation, Dr. Papu Zamkaka, and then His Excellency is not here anymore, Aurelie Le Chevalier, and Prof. Neramondo, the CEO of NRF, our guests. I think we had somebody from the presidency here, as it Mr. Lawrence Matemba. We had Dr. Fedi Ungwana from the Department of Health. And then we also have got a whole lot of other speakers, that grace us here of today, the whole day. I'm acknowledging you. Good afternoon. I would like to thank you for creating time to come and share with us this wonderful work that you have been doing related to artificial intelligence, Internet of Things, big data, with a particular focus on enabled environment and assistive living. My special gratitude goes to all our guest speakers, both local and international. We had some team here from France. We had some people from here. We've got some industry representative. I mean, I think if I have to go one by one, we will now add again another 2 hours to the day. So allow me to just, summarize all those people that has actually, touched on pertinent things. Of course, I have to thank our DVC who's still here from the morning to now. She's really committed to our course. As a faculty, we say thank you and for cheering us on. I would like to thank the VC. He's already gone, but he came and will open up this session. And I think to get time from his calendar is quite something special. So we appreciate his presence. I would like to thank, of course, the ambassador. Let me get it right this time around. His Excellency Le Chevalier, who shared with us how French government has committed to the cause of collaboration. I think it was said that it was about 25 years by now that have been here supporting our cause. So we welcome him, and we thank him for creating time and come and share with us that collaboration, how it started and the value of the collaboration from the French side. Of course, we also heard this morning that this collaboration was really, Tata Mandela actually signed the first MOU, and that was a significant turnaround, I think, for us as a TUT, because you've heard the numbers of the students that went through this program. It's really amazing. So we appreciate the fact that the ambassador created time and come and share with us, the thoughts and the background. I must appreciate the delegate from the NRF. I think it was Mr. Johnson Pillay, who shared with us, how the NRF continue to support the cause of creating knowledge and skill development. And they show this support every year by, budgeting and giving us finances to invest in research and development. So we appreciate that support. Without the NRF money, a lot of the things that you see here, it wouldn't be possible. So we appreciate that. Colleagues, we also heard, from distinguished guests, Mr. Fedi Kongwana, about how the artificial intelligence has helped during COVID. And then we also heard about, I'm gonna just pick up, the one interesting things that I think that they are pertinent for me. From industry guests, I was actually sitting there listening to this keynote address and thinking how we have, progressed as mankind in this journey of artificial intelligence. I have listened to Mr. Tim Nogalas, and he was talking about, the networking side. The idea for me for network becoming sensors and, being able to, to do things in a rapid way in this world. I think that's just mind blowing. I was talking to him to say, wow, imagine that world, eh? And now I'm still having problem with connectivity in Teams, but that world will be an exciting one. I would like to leave that and see that. And I think the talk from Mr. Stephen, about how they use artificial intelligence to decode different languages. And I'm thinking, imagine when I'm at vendor there, my mother, she's getting old, she's 85. Imagine if I can have some kind of technology that she can actually engage with Luna, for example, and tell Luna, look, I'm not feeling well today. Can you call the ambulance in vendor? Atiko, the Pazwabo, the Fonlani ambulance. I think that will be incredible. So we are really getting into a space where it's going to be exciting. I'm excited about the research and innovation that is being done in this space. And let me thank colleagues, all our industry partners. It's a lot of them, from Telkom, Nokia, Ordelin, Atos, Toyota Motors Europe, Siemens, Henry Hodder Hospital, and then the latest one, the Cosmis SA France. I think they created time to come and engage with us and to share with us the important work that they're doing in this space of artificial intelligence and augmented reality. So I would really like to extend my gratitude to everyone that has actually, speak here today, even if I didn't name you in person, but know that we really appreciate you as a faculty, and then we value you and we value the work that you are doing. I think the day was filled with thought-provoking engagement and scientific discussions, and we are indeed, as a university, we are indeed a university of technology that make knowledge works through research and innovation. I think today was an excellent demonstration of what we can achieve when we collaborate with each other. I should also like to thank the research chair, I think Prof. Joanny, for initiating this research chair. I know how hard work this is. Thank you. Where is he? I cannot see him anymore. Probably running around. Can you stand up? Can we give him a round of applause for the excellent work that he's doing? Yeah. I must say, for those of you who doesn't know, this is the fruit of the collaboration, right? The SARChi collaboration. So we are truly, truly grateful that SARChi could send us people of this caliber. And there are many of them, I can see them, that form a strong team that really has impacted our faculty and the university and the country at large. Because if we were to trace the work that they did, it's amazing. So Let me thank also, the management of SARChi, Prof. Anish Kurian is there at the back for the excellent work that is doing at that SARChi. I mean, it is, he's shaking his hand. It's really good work that we're doing. We acknowledge your leadership. All this wouldn't be possible if it's not for your leadership. So we acknowledge you. And let me also thank our Assistant Dean for teaching, for research and innovation, Prof. Munda. He's everywhere, you see. I can actually forget that it's for research and innovation. Prof. Munda, thank you for your leadership. Excellent work that you are forging ahead there. At the head of Department of Electrical Engineering, I didn't see him here today, but they form as a base, where this thing is taking place. So I would really like to extend my gratitude to him as well for the leadership and the support that they're giving to the team, FSARChi and the chair. And the staff and the student of the electrical engineering and TUT in general. I see some staff member here, Prof. Nico Stein. I see the student, I would like to thank you really for participating and engaging in this chair, because without your participation, a chair is just a name, but the work that you put in there, it makes the product that we see today. So thank you for contributing. Last but not least, I would like to thank, the program director, Rita. You did very well. You conducted us well. You managed the time well. So I'll thank you for that. I would like to thank also every single person. I've seen from people from the research department here were busy helping with the arrangement. I've seen some people from our faculty or from corporate communications that have really worked tirelessly to transform this hall to become what it is today. I mean, when I entered here this morning, I said, wow, it really looks stunning. So the brain behind this, the hard work behind this, I would really like to thank you, because you really work together as a team. And of course, as a team, you can create magic. So colleagues, thank you. And I would like to invite you to join us this afternoon, or straight after this, for a cocktail function. Of course, you must observe the COVID-19 protocol because we are in that era. But I would really like you to just take time to network with us so that we can get to know you a little bit better. And let's find out these opportunities that we can collaborate on as we engage and we network moving forward. So tomorrow, the program starts sharp and early. I hope we're gonna see you, either here or virtually, and you're gonna contribute to be great delegates and speakers as you were today. So thank you very much. Thank you.
Ladies and gentlemen, we have come to the end of the program. I'd like to thank you for your participation. And to those that have been joining us online, thank you so much for your participation. As Dr. Kanakana Katumba has mentioned, please join us for the cocktail function, and also to continue engaging the exhibitors for their technology demonstration. Thank you so much. Do enjoy.